we can see in this map that the co-location of data centers, most of them are in the USA, 40% of them. But the biggest data center in the world is going to be built in China with an area of 585,200. Incredible, enormous structure, almost as big as the Pentagon, just for data storage. It's a single level just for data storage. Yep. This is okay. This is how a data storage facility normally looks like. This is a traditional. It's single floored, and we see a lot of technic facilities to cool and to provide energy for this facility. We see here that it's most of the time it's very disconnected from the city. It's in industrial areas, and it looks like an industrial building. People already started to challenge the energy consumption of data centers, and they mostly to reduce the cooling costs, and they already started to position or to find different locations for these data centers. For example, Facebook's data center is in Sweden, above the Arctic Circle, so they use the outer cold temperature for cooling the data centers. Also, they are put in shipping containers, which are modular, and they also use the outside air, for cooling the servers. These strategies for cooling, this is only a small amount that is going to be saved. It's a small step towards the right direction, but still it's a very small step. Apple very proudly claims to have the first self-sufficient data center, the first green data center, although I'm not in the same opinion as they are, because they provide 100% of the energy via renewables. They have this enormous photovoltaic array that is 10 times bigger than the structure itself to produce the electricity for the structure. And this is, again, a very interesting question, because green doesn't mean at the same time that it's very efficient, because how can this enormous photovoltaic array be only for this small structure? So this is also one point that I wanted, and I think I achieved to challenge in my design, that I will show later on. In order to find the perfect suitable location, I did an analysis of Barcelona, a connectivity analysis, to see how well connected is Barcelona. I started with looking at the Flickr images uploaded. Where do people go? Where do they upload? These different colors showed tourists and locals. And there's also a way in Grasshopper to modify this and to follow the people based on Twitter or Flickr hashtag searches, so you can see who is possibly local and who is a tourist. This is a Scintilla open source sensor platform. These are the sensors installed in Barcelona based on the platform that provided this information. And we see, again, they are very located where most of the tourists go. So this is the traffic cameras. This is the Wi-Fi hotspots that are in the city. This is this map I generated via Grasshopper based on the data that I found in the Barcelona government webpage, and this shows the 3G coverage. So I asked myself, okay, well, why do we have somewhere 4G? Why the telephone always switches off from 4G, 3G? So where do we have the best connection? This shows the 3G. This shows the 4G coverage, and this shows the optic fiber network in Barcelona, where do we have the best lines for connectivity. And this is all in all, put everything together to see how well connected is Barcelona. And I'm not very interested in the areas where they are the most connected. I'm more interested in the areas that are less connected, in order to introduce the data center and to revive this whole area to make it more connected. So I was looking in particular in the area of Santa Adria de Besós. And here I continued my research on energy production in Barcelona in order to have this equivalent. So here first show the rondas to see a border of Barcelona, how it's not the actual border, but it's like it very well marks the terrain of Barcelona. These are the data centers in the moment, and the yellow spot is the supercomputer that we are having in Barcelona. This is the two main spots for energy generation. It's one is in Bezos. This is like two energy producing islands in Barcelona, and both are located near the rivers. So these two rivers got very interesting for me. In particular, the Bezos River interests me a lot. This area, and here I have visualized the high voltage electricity network, and we see again that the main substations for entering the city are again near the rivers. These are the Santa Coloma, the Sant'Andreu, Bezos, and L'Hospitalet. Every one of them is entering the city near the rivers. Here I have chosen my site, and with this site I also saw that there's going to be built a UPC campus based on energy research, and we have this Moncada sewage treatment plant that's also interesting for hydrogen production, for example. And yes, this whole area is it's very suitable for energy research. Here I did a solar analysis, since solar is the main source that we can get energy from in Spain. And I worked with solar and combining different strategies. Here, very fast, the urbanistic approach. We have the one site on the ground. One moment. This is the site that I'm working on, and this is the Parc del Besos. So we have this ronda, this street. This street very much separating the site from the rest of Barcelona. It's showing this border, and I wanted to overcome to jump over this border in order to connect the Parc del Besos with the site that I'm working on with the other side of the river, not to go where the streets drive, but to create additional bridges for this area. So these are the connections, and also very important. I wanted to create this connection because this doesn't exist in the moment. You cannot enter the city via the main, to enter the site via the main road. This one, you can only enter from this side. So this is my approach. I will explain later on in detail what do I do with this site and what is about the structure. Basically, I took a solar strategy via a solar updraft tower. This is a greenhouse in combination with a chimney. That's all. It's very simple, but it cannot be very well combined with other solar strategies. This is the main structure of the tower that I'm working on, because the key point here is modularity, because with modules you can create the most efficient way to have a data center, because you can use as much or you can provide as much energy as going to be needed. You don't have to cool additional space that you are not using, like they do in the moment. They have big facilities and most of the space is unused, but they still need to cool the whole facility and to provide energy for the whole facility. These are the connections with the bridges. So I want the data center to be also to be accessible to the people, because my towers will be my centers will be up, but in the ground there will be, in the ground level there will be offices, and there can be attended workshops, and also to have guidance through the structure in order to understand data, because the data belongs to the people, to its source. So that's why I want to combine this area with, because a data center also follows the best internet connection, and people follow internet. So to have a public space in combination with the best internet communication can be really nice for the site. This is the strategy that I'm using. Again, the explanation of the solar updraft tower around the ground. And I will combine the solar updraft tower, the greenhouse, with with photovoltaic arrays in order to get additional energy output, because photovoltaics work only at 15% efficiency because they got overheat. But since we have this greenhouse on top, you can use the heat and run it through the chimney in order to spin turbines and get additional energy. This is photovoltaics and solar fail when it comes to store energy. They need batteries. The best way, or the most suited way to store energy, is via hydrogen in the form of gas. So this is, I will generate hydrogen via electrolysis, because electrolysis, you electrify water, separate the molecule into hydrogen and oxygen. Oxygen, you run again through the chimney that I will explain in the other part, and the only byproduct of this is water. So hydrogen can also be, like I showed from the sewage treatment plants, in the form of methane. You can also get the hydrogen from, but I will use hydrogen through electrolysis. This is the solar updraft tower, the reference that I found. It was in Manzanares, Spain. It was a prototype. I think it worked very, very fine. The output, of course, only via this structure is not enough to provide for the whole data center, but combining with other things will give enough energy. This is now the tower, and in these sections we can see here that we have the energy production unit underground that's happening. We have the greenhouse, the data storage modules that are like container base, 40 feet or 20 feet. And we have the chimney that is the structure for the robotic arm, like the Wolfsburg car towers that are storage devices for new models of Volkswagen. And to be also the chimney where the air goes from the greenhouse up to spin the turbine. This is the main electricity generation strategy via the updraft effect. And we can see here that the hot air, the air is being heated by the solar rays, and it's forced to go somewhere. And the only way to go, because it rises, it's via to get out of the chimney, and it spins these turbines in order to generate electricity. This is what I talked about. If you use transparent solar panels that are being invented now, you can get additional output, because solar panels give you direct electricity, but at the same time they also provide heat, and this heat is going again through the greenhouse, going again through the chimney, and provide again additional electricity. This is the cooling strategy, and the cooling strategy, of course, it's the best suited is to use the liquid from the water from the Bessos River, because traditional cooling with fans is very expensive. It's very space demanding, and liquid cooling reduces the cooling energy by more than 50%, and it also reduces the density by more than 250%. What we can see here, we have water pipes. Water pipes down in this area. One pipe always gets the water up, and one pipe gets the water down. When the water falls down, because the minimum here it's 60 meters, the maximum up there is 250 meters. So the free fall from the water generates in this turbine down there, generates additional electricity. 20% of this electricity that's generated is used again to pump water via the other pipe up, and the other one is used for the electrolyzer in order to provide the hydrogen. This is the hydrogen storage. This is the hydrogen production strategy that I talked about. We have the water entering from the first pool. The water is entering to the electrolyzing pool. Inside we get the energy, the electricity we get from the turbines that are for the solar updraft tower, and we get also electricity, like I talked about here, through the turbine. This electricity is separating the water and is storing the hydrogen, and the hydrogen is run through the pipes again in order to provide each unit with hydrogen. This is the designed unit, and we have this unit. We have a hydrogen fuel cell in each unit, because the most important way or the most efficient way to produce enough electricity for this structure is to have the whole module as a separate data center. That means that when you dock in the pipes that I was talking about that have the water and the hydrogen, fuel and give energy, and also cool down the whole data center. So these modules increase over time. These are few visuals of the data center that I will show very fast, because I think my time has finished, and I'm happy to help to answer questions. Thank you.
Okay, thank you, Bobby. Thank you. Thank you for this very clear presentation. I like also very much your approach on all this energy issue with this history today of Barcelona, all the different points and the sites also of your project. Seems to be very pertinent. And I have a question about the scale of your infrastructure,
Yes.
because it seems to be a large scale in a tradition of the large technical system. This system, as it was theorized by all the historians of technology since the end of the 19th century. But with
Yes.
data center, we have a kind of new infrastructure, because it's kind of infrastructure of our 21st century. And what about, yes, this very large scale and the integration in this site? Because in this area of forum energy, we have more medium scale technology infrastructure with this solar panel, all the public space accessibility, the CHP power station, and yes, what about this very large scale?
Yes. Okay, if I remember. Okay.
Okay. Thank you for your presentation. I also find I find it very exciting, the fact that we do have now the need of new infrastructure such as the data center, and therefore we need to find a new architectonic language as well as an architectonic system for those infrastructure to be implemented inside the city or in the periphery of the city. So to start with, I think that it is a very interesting topic and program that you decided to work on. I do appreciate all the effort of trying to think that this is a system of generating energy, become totally self-sufficient in terms of energetical, let's say, demand. I do appreciate your depth, your deep research onto understanding what kind of systems could be implemented, such, for example, working with hydrogen and understanding the problem of energy storage. What I would like to see a bit more implemented into the project is, again, we're commenting a bit about this in the morning, but how those needs are becoming architecture. Because when I see a tower that it resembles a lot the office towers or the residential towers that we have been building or we have been rendering the last years, I think then we have a problem. Especially because we're talking about, on the one hand, I like the fact that it is becoming a landscape, a landmark. On the other hand, I do find that it is following the same language as the high scraping or the high towers that we have been building or drawing for the last years. So to me, the challenge is to understand how this could be the way that you are describing it, like kind of a distributed data center. Each unit can function independently. Can we then think that it's not in a vertical axis, but it's a bit differently distributed in the 3 dimensions? Can we take advantage of the subterranean for such infrastructure, or do we want everything to be on the level of the earth? And how can we take advantage of the of the plot in order to use this even as a structure to create other kind of spaces. Because one thing that I also miss is how is this being used by the people. You are talking about public space, the creation of public space, but I see no person in any of your image or your drawings. And I would like to understand how this could be populated or occupied by people, no? And how it can give an answer to the scale of the person as well, at least in the public space, let's say, level.
Okay.
Otherwise, I think that it is a kind of an interesting topic to push forward, let's say.
Vicente is very strict with the times. I don't have time to congratulate you as you married. I go directly to the top. One question about the symmetry in. It's for me strange because these are a little. I think it's an epic vision there. When you use the symmetry of the tower in plan, it's not, perhaps the north is not so clear that it's the same for the south, etc., etc. And the second is about the strange perplexity between stock and verticality. All the projects that you show at the beginning were very flat, very horizontal,
Exactly.
because the stocking seems that need horizontality, isotropy. The verticality is hierarchical. You have high levels that are not Y high. You have a kind of hierarchy. There is a criteria of stocking in this vertical device, or is I don't know, by random, or what's the criteria? Because in a horizontal device, it's more isotropical. In a vertical, perhaps you need a little criteria of action or some selection.
Just two issues, super fast. Well, first is a super important topic, the one you chose, to give visibility to the infrastructures of information that they are invisible. And we have to find a way to do it, to build them now. So one, transparency. Transparency is super controversial for information, and you know about it. How this tower responds to the issue of transparency regarding information is just a monument, or it can activate the debate of transparency of information in another ways. And the second topic is contradictory with this one of transparency. You know, the best part of the waste to energy plant that is right beside this thing, the best part of this plant are the roots, the things that you don't see. Is when this waste to energy builds roots that connect the whole 22 watt until here to give heat recovered from the waste burning. So more than generating or being worried about generating energy to feed the information, I will think it the other way around. How I can take this heat that is a problem for me and spread it and give it away to the city.
Okay.
Just very quickly, I think the way that you can address the iconography and the questions with regards to the vertical form is very simple. You can think of this rather than an object, you can think of it as a system, right? So this is the system at 300%. What does the system look like at 50%? What does it look like at 25%? What does it look like at minus 10%? And I would encourage you to take the first part of your presentation, which were all these extraordinarily intricate maps, and in pulling the lever, 100%, 300%, 500%, how do you reconcile the object with the network that already exists? I mean, how does it affect everything around it, both iconographically, but perhaps infrastructurally as it returns back to the... I would encourage you to think of it as a system and then integrate it.
Just to say that I mainly agree with all the comments. Just one thing that I could add. Given that all this technological machinery that has been built until now, it has a short lifespan. I think your building infrastructure should take into account that. What happens when it becomes derelict itself? How, because I find this a bit of a too much of a monument rather than something that it operates and even accepts that one day it's going to be superseded by some new technology, and how would you scale it down? Just as
too much. First, about the scale nowadays, what I also talked about the China, they are building they're building data centers where the land is cheap and where electricity is cheap. So they have the space and they buy huge space. So they make the single level. So they spread it out very much. But I believe that when you think of modularity as the key, you can create a modular growth over time in the form of vertical. So you don't have to buy the next possible space in order to, like what they do in the campuses in the USA, what they buy one plot, and then when the plot is full with servers, they have to buy the next one, or the next one, or they open new data centers. So I wanted to challenge this in Barcelona to say, okay, we have this data. This can be with this modularity. This can be everything can be RISE or kept at the 20%, for example, of this. But I wanted here to show that we have the possibilities to grow. So yeah, this was one of the scale. The rest, I understand also very well that this heat that is pushed through the chimney, I could find a way to not to run it through the chimney and the atmosphere, but to keep it and to give it like a district klima, for example, use the heat from the waste facility and use it for providing heat and cooling for the district here. This is a good comment for later. Yes, I yes, I like all the comments, and I will push them.
You have time now to give answers.
I mean, I could also
you answer everything. No, I want to make a comment now. Okay. I want to make a comment at the end because because what I would like to say is that you start from let's say a difficult position because you were trying to understand the structure of the data and the city, and then we were discussing that it would be great to research more about this new typology. That is what happened when the city wants really to store the data, not in a distributed way, because what is happening is that such a new kind of artifacts are now under development in the world, and the question of energy is fundamental for these questions. So I think at the end I am absolutely very happy with the result of your work. Yeah, no, I am really very happy, but I think that what he says is true. I would like to be a bit, because to be a bit stored in this place with so fantastic views is really fantastic, no? It's the best tower of bits in the world with the best views, no? So let's say that in the future, any house can be an hotel or can be anything. We have some days ago a workshop with IKEA about how to reuse things. And the reuse of buildings, I think that this is also fundamental for the future. But in any case, I think that it's very smart approach that you have. You discover the right place in the city, near the river, in an area that is full of big infrastructures. But in this case, instead to have a power station or to have a water depuration plant, you develop a project for a new kind of a typology of infrastructure for the 21st century. So I think that your approach is good. The idea that you use this kind of traditional chimney tower with a heat system is good, because you develop this idea of having the storage in high. I would say that from the economical point of view, this is something obviously should be studied, because obviously to work or to build in high is more expensive than not the other way around. But from the point of view of energy, it makes completely sense, no? So I think that the idea that you really make a step forward and instead to keep talking about data, diagrams or whatever, you make a building that represents the data. I think that this is really something great, no? Mm-hmm. So I would like to say congratulations, because you progressed very well during all your research time, and Again, thank you.
Thank you. Thank you.
So, hello everybody. Yes, my name is Luisa. My project is called Dynamic Cityscape. The Cityscape project is to explore the potential of an adaptive and dynamic urban network for future civilizations in Delta regions. And I will try to walk you through my process and my ideas within the next 20 minutes. So current global issues such as climate change, overpopulation, and accelerating sea levels give rise to a new perspective on the question of sustainability and autonomy of urban systems. So during my research, I have investigated different future predictions of these changes, and I finally settled on one database by IPCC reports, which predicts a best and a worst case scenario. And in the best case scenario, it's predicted that the mean sea level will rise at least 0.64 meters, and the worst is even 0.93 meters in the time from now to 2100. So 40% of all cities with more than 1 million inhabitants are located near coastlines and would be likely endangered by these changes of the future. The city of Amsterdam in the Netherlands is an example of a contemporary city which is at high risk of flooding, as most or large parts of the city are lying below sea level. So in fact, 26% of the whole area and 21% of the population is actually located below sea level. And this graphic should highlight the coordinates in Amsterdam, which would be likely to be flooded in a best and in a worst case scenario. So what would the loss of this kind of loss of land would mean for a city of Amsterdam, which is now considered quite self-sufficient? In order to identify these specific problems, I investigated the metabolic cycle of the Netherlands, and I investigated 6 different flows here, starting from the left: energy, water, food, waste, building materials, and other goods. And you can see that they sort of all interlock and relate to each other. So it's one system which is interconnected. So although the Netherlands are quite productive themselves, or as a country, they still export and import to almost all countries in the world. And in all of these sectors, this is an example of the food sector actually, and you can see how there's like export and import or exchange of goods to almost all countries in the world. So talking about the food sector, the loss of arable land as a result from flooding would have an enormous negative impact on the Dutch metabolism, especially combined with the issue I was talking about of overpopulation. So right now we need about 38 million square kilometers to feed 7 billion people. So expecting this number to rise up to 9 billion, we would need an area of even 42 million square kilometers to feed all the people, and this land availability is already shrinking. So there are, besides the loss or the endangerment of agricultural productivity, there are a lot of other negative impacts, as for example salination of freshwater sources, water shortage due to the decrease of groundwater levels, ground subsidence, or the loss of residential space, etc. So at the moment, the most common strategy to fight these issues or these problems are traditional dike and dune networks. So the costs for coastal protection, as you can see in the graph below, have been rising simultaneously with the rise of sea levels. So right now, the Netherlands spend about 2.8 billion euros yearly for coastal maintenance. The amount of sand used every year is about 20 million cubic meters, because it's, of course, always getting washed away again and the coasts are shrinking. So in case of dike failure in Amsterdam, the damage costs are expected to be approximately 500 billion euros. And in my opinion, this traditional coastal protection and these dike and dunes can't be a suitable and a sustainable solution for the future and future civilizations, because the ongoing process of climate change, which we cannot prevent anymore, will cause expenses and costs to explode. I would like to give you a short intro to the site of Amsterdam North and the area of Durgadam, which I've been working on and which is highlighted in yellow here. Amsterdam is located at the IJsselmeer, which once was part of the North Sea, but has been separated by a dike structure from the Waddenzee and has been an artificial lake since 1932. So the IJsselmeer is about 1,100 square meters large and is kept at an artificial sea level, which differs from the one in the North Sea. The area of Durgadam is located in the north of Amsterdam and is dominated by agricultural production. So the yearly food outcome, for example, is at 741 tons. For example, for this amount, we need around 17 billion liters of irrigation water each year. The location consists of 57% of agricultural land, 16% residential, some commercial land use, natural green areas, and others. In this context of the rising sea level issue, obviously the agricultural sector will be affected the most in this particular area. So this indicates, or this image should illustrate the modifications of the coastline, how it would happen at this specific site. So basically everything which is red would be water. So the losses of land in this area would be about 91% of the agricultural land, 70% of all the residential area, and 56% of the commercial areas. So I am proposing to consider the water surface as a valuable space which should be considered and used to cover for eventual losses or damages. Imagine we accept a certain amount of flooding and instead of fighting the water back, which will cost us enormously, providing new urban habitats which can actually adapt to the environmental conditions and changes. So I'm proposing to create an ocean habitat which can be autonomous and self-sufficient as an entity itself, but which can also feed back to the existing city, respond to its needs, and have a beneficial impact on it. So I will, one second, show you the initial network strategy I started with. So basically, I am working with an agent system which should achieve a methodology which implies a dynamic and constantly changing behavior. So we have these agents which move on the train according to different parameters and which interconnect and form a sort of network, which is the base for my future design. So I experimented with different variations. The network can be modified according to different factors, such as attractor points and forces, emitter locations, and of course amount and lifespan of the agents. So as you can see, there are a lot of different morphologies which can be achieved, and I experimented with the parameters to achieve the best solution for my case. So this is the site again, and in blue here we see the emission points. It's in fact the deepest points in the area, which I found logical to choose. So in yellow, those are the attractor points, which I chose to be roads, highways, and residential areas which are not affected by possible flooding. So the agents are emitted and will move on the train trying to reach the attractors. Then they will be connected via proximity, and the shortest path will be extracted and used as the basic network. So finally, I settled on a square base grid, let's say, as I found it more convenient to further urban development. So in general, I showed you this because I wanted this. It indicates it's like a translation of what I want to achieve, like a dynamic behavior which can change, which can adapt, like the agents do. So starting from the base grid, I started to work in more in the three-dimensional space, and I achieved this kind of topology, which is achieved by extrusion forces. And in fact, I just defined extrusion anchors, which will pull the topography and create this kind of gradient topography. So I get a very dense inhabitable core, and on the outside, it will be used mainly for farming. So the cluster will be accessible and connected via shipping transport. There will be several new landing piers which allow the connection with the existing water traffic as well as with the IJsselmeer, which here would be in the northeast of the site. So here we can see the interior circulation of the cityscape, which is also based on the predefined grid. In yellow, you see the horizontal and vertical circulation within the inhabitable core. In pink, those are the walkways which are leading around the farming ponds. So the space for platforms and for aqua ponds is almost equal, and we have also a large area of green space as green rooftops, which is more than 90,000 square meters. The cityscape features a variety of functions which are implemented into the structure. So there are bioreactors which are working with biofuels from algae, hydro energy in form of wave power generators for renewable energies. There are aqua farms featuring aquaponic systems, water collectors, and housing facilities, and they all together form the dynamic habitat I'm imagining. So this is a horizontal section of the cluster. In yellow, again, you can see the interior circulation, and there is infinite possibility of variations and constellations possible here. All the units are sitting on floating ponds, which you can see on the left of the image. This will allow still, even in a further process, I imagine to allow still to rearrange the units and create flexibility of the system. So the bioreactors feature cleaning tanks for wastewater recycling via algae. The facade is also used for biofuel generation through algae container. The bioreactors will provide renewable energies and fresh water, and also, for example, the algae biomass could, as a byproduct, also be used as fish fodder, for example. The wave power stations are located on the northeast side of the network, as this is the side which is facing the sea, like the North Sea. So I imagine the impact of the waves would be the strongest there, which is why I chose those locations. The aqua ponds feature an aquaponic system to provide the city with vegetables and fish. And the roofs of these greenhouses are covered with solar panels and oriented towards south. So those farms or the greenhouses would actually be able to sustain themselves in terms of energy. The rainwater collectors provide fresh water as well, and this water can be distributed within the inhabitable core. The cluster will also provide housing facilities for approximately 10,000 inhabitants. And as the population in Amsterdam has been increasing over the past years, this will provide new living space for the city and actually have a beneficial impact on it. The solar analysis shows us that most of the aquaponds will have maximized radiation to maximize the efficiency, and also the bioreactor facades are well radiated, which will improve or optimize the photosynthetic performance. So the cityscape, the functions of the cityscape are interconnected to create sort of a cyclical system within the cluster, and it is able to sustain itself as an autonomous unit and feeds back to the existing city. The yeah, it is self-sufficient in terms of water, energy, food, and waste. And the aim was to achieve an urban unit which can feature this kind of cyclical system. This system uses resources which are available at the location, which in this in this case is the surface of the sea. So I used a modular system which allows high flexibility and adaptability. So each unit is subdivided again in 16 modules, which you can see in this picture. Those have an area of 39 square meters, which is more or less a small apartment for like one person. So I imagine these modules to be prefabricated and lightweight from like a steel frame, and then they can be covered, which would allow very flexible floor plans. So you could, for example, combine or just have them individually, whatever are the needs. And I believe that there's a deep wish in our in our society to individualize and customize everything. So this would allow that kind of individualization on an urban scale. The aquaponics greenhouses will provide the inhabitants with food, and also the maintenance will be provided or performed by the inhabitants, which also would create jobs. This is the same case for the bioreactors, which will be maintained by people who actually also live there. So this is a vertical section through the bioreactors, and actually here again I have the modular system. Like in green, those are the algae tanks. They come in the same size as the living modules, so you can stack them according to the needs and in amount according to how much you actually want. The water which is collected on the top will be pumped down, and in this process it will also be used for cooling as a secondary output, and actually all the inflow and outflow will happen at the bottom of the bioreactor. So the cityscape, the dynamic cityscape project proposes a modular system which can easily be prefabricated and installed on the site. The modules can be delivered via shipping transport and can be installed on the site. This system would allow flexible morphologies and is extremely adaptive. It can be modified according to particular environmental or urban conditions or personal preferences. The cluster will provide new attractive living space to the population, and with a function in a beneficial relationship to the city. The amount of different facilities can be modified according to the local needs. Like for example, if a city needs more or less of local food production, there can just be added more aquaponds or more greenhouses. So in fact, the strategy, I imagine that it could be applied to very different cities just by modifying the distribution of functions and the adapting to the local requirements. So to conclude, the dynamic cityscape proposes to inhabit the ocean surface with a modular, adaptive, and dynamic strategy for the city of the future. It can actually start only as a couple of houses. It can grow to a neighborhood, and it could extend to a whole city. This modular approach can be, in my opinion, a solution for urban development in a sort of post-apocalyptic environment, in a society which thrives for individuality and customization. And as stated also by the Dutch company Delta Think, building on water is not only a good idea for the Netherlands, it can be a global solution. Thank you very much for listening.
Start with you again.
Yeah. Okay. Yeah. Okay. Thank you for this very clear, again, presentation. I really appreciate all the documents, diagrams. We can see the huge amount of work, and it is very impressive. Also, I appreciate this very ecosystemic vision, and also you made a very radical choice, and I have a question about this choice, because your proposal is a kind of new urban habitat in the line of megastructural aggregation. We have here kind of architecture which is very concurrent and it resists to the effect of the climate change. And when I saw all this picture, I think to the work of Paolo Soleri, Arcology, this huge ecosystemic, very dense. It was in the 70s, but anyway. And I have a question about this choice. Won't the construction of this new district aggravate the phenomenon of energy dispersion and dilapidation? And do you have any element on the footprint of this construction? Because you made this choice, okay, the level of sea rise, but anyway, we built something of huge. And yes, about this choice, it's not a degrowth architecture. You know what I mean? And yes, it's more about this choice. Okay, and about also the model. You said it's a model, and we can put it in all parts of the world. And okay.
That should be the idea.
You don't like this kind of abstraction, right? Thank you, Luisa, for your presentation. Thank you for your rigorous spirit of putting the things together. I think the analysis is very, very interesting. Your proposal is very clear. Your systematic approach is pretty systematic. So, congratulations. But I want to speak about the project, no? Because in a way, also the way that you are presenting it to us, you're pushing us to be immersed into that. And I would like to speak a bit about this, because to start with, it seems that you are ending up with almost a kind of universal approach or universal idea that could be applied to almost every similar context, right? And I think that is becoming problematic. It is becoming problematic because the freedom, the degree of freedom that you are allowing to happen is so big that I'm not very sure how well it's going to function. So I would request from you as a designer and as an architect to take a decision of designing this framework. I mean, yes, okay, it is a system. It could aggregate in different ways. It could host different kind of infrastructure for renewable energy. It could allow different densities to emerge. But what is the limit? And what is the minimum? And what are the variations that you as a designer, architect, or analyst, or strategist, or planner, you're proposing? And I think this is where our, let's say, contribution could be. So that is one thing. I would also expect, and I think it would be interesting to start to understand what is the impact of such a solution. Because yes, we can generate energy. Yes, we can filter water. Yes, we can filter air and use algae for creating a bioreactor and biomass and recycle our waste, etc., etc. Yes, okay, but what does it mean to put that thing up? No, what is the ecological footprint? What is the CO2 emissions needed? What is the economical impact before and after? Because that would also allow us to understand why those systems are not applied yet, or where could they be applied, and under what kind of limitations, possibilities, and circumstances. And to finish up, I would like that you would go a bit more deeper on how the city operates, because I think that you're missing a lot of aspects of it. For example, how is public space being organized? What about transportation? I see nothing about mobility there. How is mobility happening? You know, like, and I think all those issues should be related with your rules of game, because aggregation could be until certain level, no? Densities could be until certain level in relation to orientation or in relation to where you are in the city. So, yeah, if we could manage to put those things together, I think that it would really give a big push to the project. Thank you very much.
Luisa, Thank you. Congratulations. I loved your systematic vision. To go quickly, congratulations. I like a lot. Just to go directly to some questions. I was always very, very interested in this kind of approach, where the system is able to be system and at the same to be context. At the beginning, your how to explain your clusterization, this idea of handing scales that is there. No, it's fantastic for me. But say it's a little close of the math buildings, of the knick-knocked buildings that I wrote. And always when I am interested in this kind of structure, I say, what's the difference between a modern structure and an advanced structure? The modern is more a prototype, it's a mechanism. The advanced is more a device that is able to be adapt, to change, to be dynamic. No? And in this sense, I was a little afraid in one moment, and after, it was fantastic. It was full of images that this device, with a kind of epic, it's able to interact with not only with information, abstract data, but also with some sensorial information that are the data of the context, the water, the reflexes, the risks, etc. And it was there. No, not my question, but more my thing is, perhaps it would be good to have, just to be perfect, something about the phases, about the time, about the different steps to do this, and the different answers in the different times. No, to have perhaps at the end this kind of density that perhaps is the last and not the first. No, the other question was this. This is a system, is a device, is an abstract device. When it's in Holland, it's clear that it functions because it has this kind of interaction between reflected and irregular topographies or geometries. In other contexts, it will be good also to understand the different capacity of reaction of the same system. But congratulations, it's a fantastic work.
Very fast. Still. I appreciate a lot your work, and I really like that you're placing the data, the information to the project, and you're actually proposing the urban scale proposal. And what is interesting for me that you're developing the algorithm, but I would rather think, because I see that you're developing the generic algorithm, and I would like to see the development of this algorithm to decide when it will become the site-specific or data-specific. So how just the site specificity. That I see it very, very much generic, but still I really like your approach. Okay.
Congratulations, amazing work and super rigorous. Now, you told us like the perfect tale. I mean, I think this project is super controversial, exactly because of the part you didn't tell us. No, I mean everything was bright and working perfectly in your story, but at the same time, you know that there are plenty of things that they don't work. This is almost the contrary of an utopian in some senses, no? And you know it. I mean, you explain it from the position of the construction company that has the ownership on this patent. And there is a kind of a withdrawal of the architect from there. That is it's a kind of manifesto. It's like, if you do the things right, if you have the right data and the right prefabrication techniques, you don't need architecture because everything comes up alone. Now, Jonah Friedman was spending his whole life, like, and he's still doing so, thinking about what are the limits of thinking in this way, like thinking that the architect is not necessary if you give the rules for the users to implement their own habitat. And what he realized, like at the end of the 70s, was that there was a limit in scale. The system works perfectly. We don't need architects. Everything is fine if you have the proper logics and you distribute a kind of communication and intercommunication logic between the users. but there is a limit of scale, and there is a kind of limit that is less than a neighborhood, where systems like this stop working because communication between people becomes super difficult to make it horizontal, so it's impossible. So I will encourage you to think, what is the smaller component, what is the smaller company, or what is the smaller kind of urban habitat that you can think and that you can decide.
I mean, I agree with the rest of the comments. I'm going to keep deepening your bibliography, but Fuller has a on the water aggregated cellular unit, and in the later stages of his career, he was really concerned with things in the water. He designed tide controlling mechanisms to generate energy. He designed the, a number of prototypes. So I could speak about you value engineering your project to make it closer to reality, less closer to reality, but I'm going to encourage you something that might be controversial along thinking of Fuller. So I'm a ventriloquist for him. But I would encourage you to go into everything that is intellectual property within every part of the system in your project and really have a conversation with the proprietary knowledge that exists with respect to building on the water, just as Fuller did, and identify which parts are belonging to the discipline and which parts are not. Google Patents gives us the extraordinary capability right now to really do a deep dive and identify what technology, what engineering is geared towards dams and civil and infrastructure, and then what engineering is really closer to what we do, and start thinking about ways to translate this in a proprietary manner. Not for it to be proprietary, not to earn money, and not, but just to have that conversation, because you can really, rather than value engineering with parameters that we conceive to be, there are people out there value engineering things against proprietary knowledge. So that's an angle of the project that I think is interesting.
Just one comment along Rodrigo's comment. I'm looking forward for climate change. The way you've painted things, I'm not scared of it suddenly, which it's a bit worrying somehow. I think on a more serious note, I think we need projects like yours. I think it's a problem that is coming. It is the responsibility of your generation, not mine, to tackle this. No, we're not. You know it. Well, I'll leave it there. Thank you. Good project.
Okay. Yeah, well, I'm not sure if I can answer all the questions, but in fact, yeah, I sent this presentation to my father, and the first question he asked as a non-architect, will it be fun to live in this city? And well, I'm not sure if that's the approach you should have, but I think what I'm proposing here is more like a big vision, like an extreme, and talking about fun. Like, I don't like to have limits, and I don't like to think about limits. I know we do have, but in this process, I kind of tried to push the limits and make a very extreme, controversial approach, and just try to stretch the limits.
Okay, Luisa, so first of all, congratulations, because your development is really amazing. I was in Florida talking with the Developers Association of Developers in Florida, and I told them, if there is a global change and the sea level rise, you will be the first, the ground zero. So you have two options. You can start to try to avoid it and fight right now, and not to do anything, and start to act when everything is a disaster. Obviously, they are Americans, and they prefer to wait to the disasters in order to do anything. But this is not your case. I think that the approach that you took, I think, really has been very serious. I think in one hand, the research has been very, very serious. The graphics are absolutely fantastic because ideas are important, but to explain very well is also important. The idea that you try to develop some kind of unit that could be replicated or extended, etc., and then to start to deal about what happened with building in the water, I think that has been developed in a very, let's say, a structural way. We saw many cities in the sea. Now we saw many films after the water disaster and then the people fighting for everything. But it looks like a Dutch city. I mean, it looks like something that, in fact, we should start to build tomorrow to be prepared for any
That's right.
potential change. No. So anyhow, I think that the work you did was very consistent. I think it really was very consistent all the way during all these 9 months. So I would like to say congratulations for all your effort and your work. Thank you.
Thank you.
O tienes que cambiar de...
No, se me estima.
Pero no te va a funcionar por el doble.
No, lo usaba ya.
¿Ya?
Ahí está. Okay, hello. My name is Diego. I'm from Lima, Peru, and my project is called the Autonomy Project. Oh. Hmm? Actually, that's right.
¿Cambias de resolución?
No, la resolución era la misma.
¿Quieres que subir el mío? No, no toques nada.
Okay, I will start again. Sorry for the interruption. My name is Diego. Oh, okay. Actually, I started my thesis by trying to understand in the historical process of the civilization the relationship between the economic and the productive system and its repercussions into the morphology and the social dynamics of the city. So I basically focus my attention in the Latin American cities because after the Spanish Viceroy, the productive and economic system changed. And as a result, the cities also changed. So when we see the cities now here, like Buenos Aires, Bogota, Lima, Quito, Santiago, and La Paz, they share the same kind of urban fabric. They actually have this main square, this checkboard grid, and actually they share the same economical system. So I took a case study or the Peruvian economical system nowadays. How does it work? And actually, it's based mostly on the extraction of commodities. So these cities that are here are actually the main sources of primary matter. Then these sources are actually exported to USA, China, Japan, Canada, and Switzerland, and they are converted into final products. Then they are released into the global market economy and they go back to these cities. But what is interesting here is that these cities, the cities that are actually the extractive points, are not returning any of this product. So the poverty and the inequalities has actually been outsourcing. So then I studied kind of the entire economical system of these cities, and they are all centralized. The capitals of each city is actually concentrated the biggest amount of GDP and the fastest growth of the city at the same time. So how the economy then in this type of city is mostly extractive. So what do? They extract commodities, minerals, hydrocarbons, oil, and actually this is very damaging and harmful for the environment. So then I see how is this repercussion in the continent in terms of pollution, and all this area, all these flows are actually high polluted, and it's actually overlapping in the areas that are extractive in the same continent. So if we see more or less the points or the poles of extraction are basically located in the Andes. The Andes is a chain of mountains that is actually putting together all these countries, and actually 82 million people is living there. So I decided to see like what's happening, because what's happening in this, and actually it's not a local problem, it's not a Latin American problem, it's like our global problem. And this global problem is because of this tortuous exodus from the urban to the rural. And what happened? The rural became like the counter space of the city, kind of the leftover. And actually the urban is just the 2% of the surface and is consuming the 75% of the energy. Nevertheless, the rural area has the 98% and it's like a leftover space. So then, in the city that I mentioned before, in the country, sorry, I make an analysis on all the extractive cities, getting into the conclusion that all the cities actually have very disconnected services. The poverty is above 30 or 40%, the literacy, and all the social indicators are actually very bad. So how does the city look? What is common in the city? The high poverty and the same economical productive system that is the mining, the open pit mining that is really harmful, and at the same time is coming in a chain fostering the contamination of the area. So this picture is very symbolic. This is the city that I finally chose. It's called Cajamarca. It's in the center of Peru. And why is it symbolic, the city? This picture I will explain you after the morphological analysis, where what we can see here is that the city is basically transversally crossed by rivers. So then when we see how is the public space through this methodology of the Hugh-Barton radius of influence to see how compact is the city or not, we see that there is a bigger concentration in the north. And then again, when we see the institutions, how is the concentration of the institutions, educational and so on, they're also in the north. And when we see a commerce, how is the commerce flow? Again, it's in the north. So when we start thinking why this city kind of concentrated in the northern part, is because there is a mine 3 kilometers up in the north, and the mine is actually working as an attractor point. And this mine actually is this image that I showed at the beginning of the two girls sitting in the horse, is in this kind of fight, civil fight between the local public, the local citizens, and the government, who are actually against making a riot because they wanted to build another open pit mine, and they want to destroy all the resources and take out the water and the lake. So this economy brings repercussions that are physical, that are tangible, and one of them is the water policy management. So as I showed you before, the city is based mostly between rivers, but what did the authorities do? They build highways on top of them, and this altered the entire ecosystem of the city. So what happened? The city, when there's too much water, when the surface of water gets flooded. But what happens when the water gets a little sky? It gets dry. The city gets completely dry. So this paradoxical situation is actually enhanced and fostered by the economical system. Then I make kind of an analysis or a diagnosis of the city in 7 sections in 3 different parameters: the economical, the social, and energetical. In the economical, actually, there's no big economy, there's no industry, it's primarily extractive. The people living there, the 70% dedicated to agriculture, who represents the 21% of the GDP. There's no renewable energies, and there's poverty, literacy, lack of public space, and a really, really low density. So what is happening in the city? How can we change this current situation? What can we do? So when we think about a productive reconversion to diversify the economy, this is the amount of the money that is in the budget of the municipality to develop some infrastructure, some projects. And actually this amount of money is bigger in the city of Copenhagen, bigger than Stuttgart, and bigger than Lyon. So then we understand that it's not an economical problem then, it's a political problem, it's a problem of policies. So when I kind of research in this value called economic complexity, the economic complexity says that when a person is exposed to technological advantages and to challenging work, the productive and economical system at the same time as the social capital grows. So how can it grow? How can we convert this? By transforming the thing that we extract. A simple process, because extraction takes 75% of the labor and just the 10% of the income, sorry, and the transformation just takes the 10% of the labor and the 70% of the income. So I decided to make this city reconversion in terms of 3 layers lately. The first one is energy. So as I mentioned before, the water policies are very important. So I researched all the rivers there, their flows, and how are they creating the urban poles and the agricultural poles. Actually, they're not creating what is very curious, that they are not creating that much, even though there is water in the city. So what I found there is like the emissions of the river, that is the natural bifurcation based on the geomorphical conditions of the city, are actually fostering control areas that can be potential projects. And the biggest circles in the right are actually the locations of the biggest flows of water who actually can perform as hydropower, hydroelectrical plants, for example. So what I found, eight poles of who can be potentially become hydropowers. Then when I look at the wind, actually the wind is not that strong, but it's constant during the entire year. So how can we get energy from the wind, not by the wind turbines, but by the impact of the low frequency vibration, who can actually produce energy and store it in small devices. Now, how is the radiation? The radiation is mostly near to the mountains, that is in the left, is more cold, and in the agricultural field is completely hot almost the entire of the year. So this is the year radiation analysis of it, so we can kind of understand what is the big picture during the entire year. Then I make a research according to the devices that are actually now available, according to their capacity to perform and to obtain energy, and according to the scale that they have. So I choose for the photovoltaic panels, the solar thermal panels, the low frequency vibration to get energy, and the hydropower. So then, how are the numbers? How much energy can I produce with it based on the energy resources? I make a calculation that I will a little fast on it. So actually, I will produce around 40 gigabytes hour per year, which is actually more than enough of the city to run in a year with their own resources. Then the food production, as I mentioned before, people here is dedicated to agriculture, most of the 70% of the people. So what we have to do in this agricultural production is to diversify, just not to sit and harvest. So this is a seasonal chart with the water availability. It's kind of abstract, showing the calendar and more or less how is the availability of it. So I will take this into 3 proposals. The aquaponic proposals in the urban area where are the abuses of the year happening. The high-tech croppings, who will be kind of the key for the economic complexity to be achieved by actually taking out the farmers from the fields and putting them into develop the transformation of these projects of these vegetables and fruits and there's the processing. So this is the calendar based on the water need, the resilience of flooding and drought, what is necessary, the pattern, the technique of the irrigation, the work need, and the sun. And these indicators are actually explained here. Then this is the overall calendar. And this chart is important because it's actually putting into perspective the amount of people that you need to perform these activities, how the amount of food will be processed, and how will be the surplus of this will be exported. So because we're talking about association, we're talking about agrofields, it's important that based on the calendar we think about how to associate this type of crops based on their qualities. So then, how do we deploy the proposal for the aquaponics? We took actually the intersection of the rivers with the biggest flow near the bushes with the arterial roads. So we have the biggest concentration of this micro-urban productive unit into the city, creating 22 new poles of aquaponic system that kind of will release and decentralize the agricultural production. Then, for the high-tech cropping fields, when we are talking about different poles and the connection between those poles, I make a parametric concatenation between them, actually by different parameters. How close are these poles? How should be the connection of it? And it should be multiple or not, and also the flow of the river that has an input. So this connection, the biggest poles, then the connection, but this is just one connection between each pole. What actually what we need is, because of the cropping system, is to connect more of them at the same time. So actually this geometry is actually helping to enhance and to foster this type of association. So then we will deploy this into agricultural fields where actually these micro channels, micro floating units will help to, as a way of water policy management, because they can store water in the fields when there is a surplus, and actually they can redistribute it when there is not enough water. So we'll have 29 reservoir poles, 23 micro unit cropping poles. So we will produce enough food to feed the people for an entire year based on their autonomy. So then how is the urban production? Actually, the urban production is taking into the consideration of the densification of the city, because it's actually very, very low dense, it's 2 floors. So when we see which type of housing is normally there, we can realize that more than the 80% of the housing is private, is independent housing. So, and then when we study the household structure of the city, actually the couples with 2 children is the most common and regular type of family. So then, in order to densify this, I make a study on spaces according to the users, which have a specific amount of area, which a specific amount of units to produce in the future, and then they should be individual or shared. So this is the new amounts of units per each code. I will pass this fast. So then how to then, what is important here is the association between these units of habitation. So as well as these units are only basically living for living conditions, how can we mix them with other spaces? So I make an analysis between the relationship of the flow, the BCR, and the FAR. And what I'm obtaining for this is kind of a zoning, but actually it's not deterministic. It can actually vary, and what is important here is that we are changing actually the spectrum of having just private housing for having more collective housing. So how is density going to be applied? The density will be applied parametrically according to the rivers, who will be the new productive public spaces, and the main roads who are actually having the most quantity of social dynamics and social interaction between the people. And how this new public spaces will work? They will be in a 500-meter radius, so everything will be walkable. So then how do we think this extrusion should be? This is a model of how it should be, because what is the problematic now? The problematic is that this area is located near the tectonic plaques, so there is earthquakes there. And because almost 98% of the housing is informal, if there is an earthquake, everybody will die. So in order to densify the city, to build on top of the city, we will have like a reinforcement structure. That will be the foundation for the extrusion. So this extrusion will have actually this envelope, because the lighting and the surfaces that will be exposed to the solar radiation are better. And we will have new regulations. And we will add the solar thermal panels and the photovoltaic panels. So every unit will produce their own energy at the same time. So, but what is important here? The important here is the public space that has been dismissed from the city. The river has been actually covered, and actually is very, very dangerous, and is actually damaging the environment of the city. So I propose to retreat this river as productive units. So we deploy here the aquaponic system, and we will have a kind of a different morphology of the city based on this new type of economics. This is actually not a layout of design, this is just one personal approach in one specific unit from the 1,000 units that we will have there. So this kind of density logics will expand towards the city. So the master plan composition actually will explain fast. This is for territory, how the mobility should be based on regional roads, and the roads that are connecting the interior of the city, the moving areas that are actually between the new ones that I'm proposing in the empty plots and the existing ones. The density, according to the colors, the bluer, the more dense, based on the attractive path that I showed. The public space, that they will have 48,000 linear meters of public space. The energy sources of that will actually help the city because we have in the north, as I mentioned, in the upper part, sorry, uh, 5 sources of hydropower. And in the bottom part, we have the biggest radiation. So we have the opportunity to actually use this energy to produce for the city. The food, again, how will be distributed in the aquaponic poles, in the high-tech cropping fields. So this is with the same parameters that I need my diagnosis. I'm doing this kind of not a layout, but this kind of proposal of the master plan where I'm having high-tech cropping, reservoir irrigation system, food storage, flooding control system, and so on. So then this is the kind of the final data that the city will get in terms of production, energy consumption, food production. So when we, as I mentioned before, there are 3 key points: is how to produce energy. So how to make the approach of it, how this infrastructure should be. So when you think of how the infrastructure nowadays, when people want to densify, when people want to make the city big, what do they do? They actually create more highways. So actually this should be changed. When we want to produce energy, what do we do? When we want to treat water, what happened? We have this big infrastructure that actually eating the entire surface. And what do we do when we want to store water? We have a reservoirs that are so big. So my proposal is to create an integrated system who's working as a unit and actually is creating food, heating, electricity, clean water, and effluent for the agriculture. So how should be this new infrastructure? How this should be? So I took like a metaphysical approach based on Gilles Deleuze, who's actually saying that the body conceived of as a mechanic assemblage becomes a body that is multiple. Its functional meaning no longer depends on an interior truth or identity, but on the particular assemblage it forms with other bodies. So actually this is kind of translating the fact that we don't need like normal dams, we don't need to deploy solar panels all over the world. What we actually need is how these elements can work together as a cycle and how this cycle can be distributed. So I started with the first element, who's going to be in the upper part of the mountains. So I understand that what do you normally do when you need hydropower? You build a dam. So what is doing the dam? It's cutting it's naturally it's cutting actually the natural conditions of the site. So this is kind of a mechanic assembly. It's a machine. By the cycle that I explained before, I deployed vertically in the same formula that you saw before is actually happening in this place. So what is this kind of device doing? This device is taking the water from the bottom, the gray water, is processing, is taking it into the filter in the middle, and is pumping the water up. So actually, this device is becoming like a power plant by putting the water up and after releasing it, getting energy from it. So this we will get energy, heating, clean water, and landfill soil for the agricultural pole. So then, how is the city? The city, as I explained with you, will also produce their own electricity, their own heating, and their own water. So then, how is the water policy management? How is this device that should be deployed in the agricultural fields? As I explained before, there is a flooding problem. So this device will actually, when there is a surplus of water, we will get through this, we will gather the water and we will store it in the upper part. The skin is actually based on the radiation, so but because there is a huge radiation here, the skin will protect it from water to evaporate. So this actually works as a cycle in the entire city. So we distribute the economy, and the economy now is reconverted into diversity. And the importance of these actually devices is how they apply the logics into the city. And this is the image of the high-tech cropping fields, where actually the people is not anymore harvesting or seeding, but they are in the way of processing fruit. And this is the towers, the devices who are actually working as waterfalls in order to produce energy and to clean the water. So actually, I will show you now a video.
So this water is actually deploying to the city, creating the first push of the energy, creating the micro units of aquaponics. Then what happens in the middle of the year? The city gets dry, naturally gets dry. There is resilience. So these units, the towers that I showed you before, are actually storing the water. And when the city and the rivers start to get in drought, they start to release the water that is being stored. So the water policy management now is not is kind of enhancing the economy and is enhancing also fostering the diversification by giving the basic conditions for the city to grow. So then again, when the cycle starts, this gets pumped back. So the city always have water, who's actually very important for them. Thank you very much.
I don't know. Thank you. Thank you for this very dense and quick presentation.
Sorry.
I really appreciate all the work, for sure. We didn't have time to go through each diagram and so on, but we can see all this impressive work. You work at a huge scale. It's kind of urban global design, macro resource project. And I have one or two questions, goes in the same way. The first is how it's integrated into the local construction or energetic tradition, because you don't tell us about this.
Sorry?
You don't tell us a lot about this.
About what? I didn't hear.
About the context.
The energetical
traditional local construction tradition or energy history or the country, or it's kind of you make a kind of a new word, no? And also in relation to the architectural biennale in Venezia, which is currently being held, and what the name is News from the Front. News from the Front.
Reporting.
News from the front. News from the front.
It's not reporting from the front.
Sorry?
Is reporting from the front.
Yes. Okay, yeah. But you see what I mean? What is the news from your front? You know, from this side and all the experimentation and that could, from your locality. What are the news from your locality? Because you don't tell us a lot about what exists and about the experimentation. And yes, it's all.
Impressive work, like impressive how you tie together all kind of scales, how you jump from one economy that we know how it works to something that is completely like a new world, as you were saying. So you propose basically to kick out the mines, no? And to start from zero, another kind of economy that can be autonomous. I would like to, now the problem always with these extractive economies is the internalization of the environmental and social costs, no? So I would like you to explore not how to start from zero another kind of path, but to use this path that you already have developed to make the shift, to kind of starting from the reality that we have now, like starting from the companies that are there, starting from the environmental damage that is already done. How do you use your systems to shift or to heal little by little this situation? Not a complete radical jump, but like a healing process, an internalization of these costs, a more subtle evolution from what we have now.
Well, Diego, congratulations, impressive. You are very strong, you know. and I think it's very interesting in all the levels: analytic level, representation level, multi-format level, and also why not enthusiastic level in the sense of attitude, not to do. There is something in the act that is incredible. That is our optimism. We are optimistic. We are epic in this optimism, and I think that here is there. Perhaps just this sometimes is the things that are more interesting for the vision and the imaginary, and sometimes at the same time is the more critical in the sense that perhaps is in the limit of the system, and with this radicality, sometimes there's something that is perhaps not so realistic. But just to go directly, the analysis and all the first part energy, fantastic, I think perfect or very well. I am absolutely interested in the agricultural part. Absolutely, I know. I will tell you in person because I am very interested now in this moment in the combination of resilience and intelligence. This is my thing, and the first part, and the second is absolutely linked. Also, Luisa is there. The third, the urban part, I was very interested there because it's a projection, it's a projective answer. Perhaps for me it would be interesting also to have with other levels, not only with this new artifact, these new devices that are a new kind of, how to explain, prosthesis, or prosthetical machines, but just some things that were only cheap, just very cheap to change the urban buildings and also the urban public space. But just this is the only little critic that I can do, and this, no? And I'm not so convinced of this kind of big elements there, but I understand at the same time that it's fantastic to finish with this, to say I push the system until the limit because I am a researcher and not only a student, and this is very good. Thank you.
Just very quickly, I also want to congratulate you for your energy and the depth of your research. I wonder, when you got to the point at the moment when you started from scratch. So I have to agree with Rodrigo that the moment you decided to start from scratch and say the existing context at the level of the unit or at the level of the type, you decided to start from scratch. You could have also, at the same time, looked at the existing typologies that are there. Is there a way to do both, right? So not not forsake the possibilities that you show on your last renderings and all that, but actually say there is a whole gradient of strategies that start literally from the roads that are there, literally from the typologies that are there. I know that in our program in San Diego, we do a lot of research with Tijuana, and water is the #1 problem, right? And the idea that you are able to control formal versus informal, the gradient, you're able to formalize certain roads that have all the systems within them, and then that expands transformatively the rest of it. There are possibilities for the existing, in other words. So I would encourage you to, while you continue to pursue the system from scratch, that you also bring in some, and maybe that feedback can strengthen the project.
Just one last comment. I did appreciate very much your analysis. I really like very much the commodities and how they move away from the cities to come back as products. But my criticism to your project would be that precisely that all that path does not inform your design. In other words, somehow, to the lines to what Daniel is saying, that he calls it starting from scratch, but I call it there is a lack of continuity, probably, between one thing and the other. I'm fine with the units, but I have my doubts about these sort of sci-fi energy generators that I don't know whether if it is. Yeah, I'm not very sure. Yeah.
Okay, I will answer the questions in order. In terms of the energetical history, actually the country, Peru, indeed has the 47% of the renewable energy is based on water. So actually the water policies in the city are very important. About the frontliner, what many of you mentioned about why did I start from scratch, is because once you analyze the historical process of the mining and its repercussions of the city, I think you have to put in a balance in a way to be dialectical and say, okay, you have the social capital and you have the economical capital. So this situation is actually enhancing only the economical capital, but it's not actually enhancing the social capital. So in the balance of it, I think the social capital is indeed more important than the economical capital. And at the same time, the city has its own resources to produce and has money because the money is destined to the budget. They have a budget, but they don't have projects. So mostly they spend the money in festivals or in caravans. So then it's not, as I mentioned, it's not an economical problem. It's a political one. In the change of the okay, what you told me about that the design is not informed. Actually, you're kind of right in a way because I didn't explain well the process of designing of the towers. But the considerations that I took are actually, for example, this tower, I took the reference of how the dams, how the height of the dams, and how should be the flow of the water release. The skin has this shape because of the flow that is impacting the skin is having the least impact possible, so you generate low frequency vibration. And each of these small panels are actually generating energy and working as batteries. These legs that look like tentacles are actually connecting with the networks of the city in order not to excavate or damage the mountain. So actually, you're right, it's not quite perfectly explained, but it has some logic behind it. Yeah, one fair scratch because I made this dialectical approach.
Okay, so again, one third project and one incredible presentation. I think that in the last 2 or 3 months, you really run and speed up your research and your development. I like very much all the different, let's say, yeah, skills of your research. I think for example, this image is very strange because from my point of view, it doesn't represent at all everything that you have behind, no? So I don't know if the Moscow experience really had influence on trying to be more radical than what you needed, because in fact all the development and some kind of very realistic approach. It was kind of 95 realistic approach until the moment you decide to make some kind of animals with some kind of a strange foundation, some kind of a strange whatever. It looks that are coming from another presentation. But anyhow, what can I say? Uh, I like very much that you have been, also with Luisa, you have been trying to follow some rules related with the idea of the self-sufficient city and the self-sufficiency, and you try to develop in different scales and different strategies. You did it very well in your cultural environment. So again, I think congratulations. I removed the S because of the last renders. Okay, thank you. Se pagan un año de libertad y hacen una cosa
Hello. My name is Zach, and I'm starting with this image by a Chilean architect and illustrator because I think it captures very well the conflict that's happening in cities all around the world today. And that's the competition for public space. This is happening in Santiago, it's happening in Barcelona, and in Singapore, where I based my project, my study. So that competition is happening between different modes of transport. And for the last 100 years or so, the car's been winning. And you can see how uncomfortable everyone is in that bus. And so each mode of transport that inhabits our cities has a range of impacts. Some of those impacts are economic. The greatest boom of American economic development that the world has ever seen. Some impacts are psychological. That includes things like bus stigma or car culture, the sense of entitlement that people often have for their cars. And other impacts are physical. And so that's kind of what I wanted to understand with my study. The idea that the way that we move through our cities impacts the structure of it. And so I started with that intuition. And so what I did was I conducted a study of all of the different ways that we've had before of moving through our cities, how some of these modes have flourished for some time and then become extinct. Some never got off the ground at all, and others haven't happened yet, but we expect them to. And some of these modes have had greater impacts than others. For example, when horse-drawn carts first entered our cities, it was seen as an interloper, an intruder, because horses and pedestrians could easily share space. But when the cart came in, it tore up the roads. It needed twice as much space, but that actually ended up with a push and pull because we ended up with better road systems. And so that push and pull is what I wanted to try and understand, because I see a technology on the horizon that is going to have an enormous impact, and I wanted to understand what that is. That technology is the autonomous car. Driverless vehicles are probably going to change the way that our cities function, and I'm not the only one who thinks so. Jeremy Rifkin also happens to think that autonomous vehicles will be the transportation mechanism of the third industrial revolution. His theory is that what he's talking about in this quote is that the infrastructure to have an industrial revolution requires a communication medium, a power source, and a transportation mechanism. And so in this book, The Zero Marginal Cost Society, he talks a lot about the first two, the internet and solar power, but he doesn't spend much time discussing autonomous transportation. He mostly discusses a little bit about the sharing economy and intelligent logistics, which are great, but I wanted to go in much deeper. I wanted to understand how that will affect our cities. And so to do that, I ended up taking the computational modeling approach. I wanted to create a transportation model that can understand larger impacts, things that transportation models haven't really done before. So here's a brief history of transportation modeling. In 1881, Francis Galton invented isochronic maps. This is a map that shows the estimated time to travel from London to anywhere in the world. And we actually still use these maps today. This is a very common form of transportation modeling. The next model is the four-step model. That's actually since it was invented in 1955 in the United States with the Detroit Metropolitan Area Transportation Survey and subsequently the Chicago Survey. It's been the gold standard for transportation modeling. We've used it for planning expressways, public transport, and this is kind of how it works. This is taking an urban area, in this case the Czech Republic, and it converts it into a network, and it loads the links on the network with traffic. And so It's how you plan the size of routes, things like subways, that sort of thing. And we still use it a lot today. It's the most common tool, but I'm going to talk more about why that's problematic shortly. The next tool that I've got on my list that was invented is the geometric network analysis, basically space syntax. So it takes a city, converts it into an axial line map, and this is essentially analyzing accessibility within the city. So it converts the city again into a network, and it analyzes that network based on the quantity of connections to a route, a link, and the angle of those connections, and you get this beautiful map out of it. And so this is a useful tool. It's used pretty frequently. Okay, and then the last two activity-based models are essentially the same as four-step models, but they go a little more in depth with the data gathering aspect. And so they'll do household analysis, how many vehicles per household, that sort of thing. And agent-based models are quite popular today, but they're mostly useful in small spatial scales and small time scales, because the agents are simulating the individual decisions of vehicles and people moving through the space. So you can't really do an overarching analysis of a city with an agent-based model. So I went and invented a different type of model. It's similar to the four-step model in that it operates with certain similar ideas. It's in the same logical space, but it's got a different process and it achieves a different result. So with the four-step model, it starts with trip generation. That's doing a kind of activity analysis of the city to provide a trip rate so that you know where people are going. And that goes on to trip distribution, which deploys those trips across the network. Mode choice is a probability calculation to tell which people are using what mode to go where, and it does that through utility analysis, which I'm going to show you shortly. And it ends with trip assignment, so that actually says, okay, this person is going to use that mode and it's going to take this route. And then it's got that equilibration loop, which is how this model deals with congestion. So it basically operates as a supply and demand sort of equation, where when supply outstrips demand, it's going to equilibrate and deploy those trips across different routes. But that's a problematic understanding of congestion. I'm going to explain the different type of congestion model that I've used. And the reason that it's problematic is we see evidence that this type of model has failed in places like Los Angeles, Mexico City, where supply grossly outstrips demand, or other way around, demand grossly outstrips supply, and people are willing to sit in traffic for hours because they don't believe that they have another option. So my model, on the other hand, starts with a detailed description of the environment. Once you've got that, you can generate trips across it. So it's a similar process to the four-step model. Route assignment is when those trips are deployed across the network, and that's different modes of transport like subways, expressways, things like that. It has the mode choice calculation, but what's different here is that it calibrates it once. You use actual ridership data from an urban study and calculate the mode choice based on that, and then you can start changing parameters. So it's more of a linear process. You don't actually have to loop back when you decide to change the network and run the calculation all over again. This makes my model much faster than traditional models, which is a plus for this sort of analysis. And finally, you get the topographic visualization. So the understanding of congestion that I've got in my model is different than the traditional one, supply and demand. I'm using something known as a congestion index. So when you travel from one point to another, that congestion index describes the difference between how long it takes during free-flowing traffic and in congested traffic. So 2 a.m. versus 5 p.m., how much that ratio is. And so that's going to affect the trip time, and if your trip time is longer, you're going to see a reduction in ridership. That's what the probability model tells you. And there's also factors like the population of the city. If population goes up, that's going to increase congestion. And that affects the vehicle population, the crash rate. All of these things combine into the congestion index. So this is the process of the mobility topography model in a little bit more detail. What's important to note here is that line through the middle of it. Above that line, I developed the model in Grasshopper and Rhino, and below that line, it's done in processing. So here we are looking at the first stages in a little more detail. You can see at the top here, there's the activity generators, expressways. That's your urban environment that you're gathering. And then the user selects the configuration of the urban environment, because you can configure it for the future, you can configure it for the past, but you start with that calibration scenario that you need. And then on the other side, there's the zone curves that you need and the data. So you construct an analysis grid, and basically this generates a trip rate, which you construct trips from, send that over to these route deployment procedures, and you're going to export route data from this process. And that data, this is the Grasshopper script for that process. You can see the trip rate calculation. It constructs an analysis grid, sends the trip rates to deploy start and end points. The endpoints are at a 3-to-1 ratio to start points to try and eliminate extreme results. You get a more consistent reading. And then it connects it into lines. You select your urban environment, and then that feeds into these clusters, inside each of which I have what I call a common sense algorithm. And then out the end comes route data for each mode that you're using. And I've got walking, cycling, buses, trains, and cars and taxis. So all of that gets handled here. This is a map that describes the trip generation process. So you can see the analysis grid put in over the map. Then there's the activity generating occupancies. The regional centers, that's where work happens. Commercial centers are where you've got malls. Special occupancies are things like hospitals and airports. These are where people are traveling to, and then you get this trip rate out of it. You deploy the trips across that landscape based on sorting mechanisms and end up with the network of trips, which in this case are mostly going to the city center of Singapore. So it's functioning well. And then this is the example route calculation for a metro. The way that it works is you have a start point, and then there's the first stage of the trip to your nearest metro station. That's got a length to it, and then you've got the distance that you stay on the train for. The algorithm collects the number of transfers that you're making, and it tries to minimize it like someone who would be using a metro. And then there's the third stage of the trip as well, your walk from your end point to your nearest metro station there. And then here's the model executed in the processing side of things. So it takes that route data. The user inputs relevant parameters. These are going to be things like your vehicle speed and the wait time for your bus, that sort of information. And so it sends it through the algorithms. You calculate the utility value and the mode probability. So these are the equations for that. It basically takes the travel time and the travel cost and also the income, the average income for your zone that you're analyzing. And it's going to calculate a utility value, and there's all those coefficients in there, which I'll talk about very soon. And then there's the probability equation below. It's basically a percentage equation. So out of this, you get a calculated modal split. But if your coefficients aren't optimized, which on the first time through they aren't, you have to evolve the coefficients using a genetic algorithm to align with the ridership data that you have. So that's calculated to within 0.1%, and so it's fairly accurate. And you end up with an optimized set of utility equations, run through it again, and you get average probabilities from each start point. After that, you can accumulate that data into trip time, cost, modal share, emissions, and you can also output a topographic map. So this is the interface for my application, and I'm going to give you a little demonstration of it. So here we've got, if you look at the television, you can, You can modify parameters like income inequality, see what effect that has. You'll see that those red neighborhoods are actually the wealthier ones. And there's no coincidence that they're where the car traffic happens. You can change the car population, car sharing ratio. There's so many parameters, and we can do it for every mode. You can change the evolution of the state of the metro network, but that of course happens in conjunction with other networks. Bicycle rental percentages, there's so many parameters, there's 67 of them, I can't go through them all. But then what you can do is analyze the metrics. You've got the average time that people are going to take on their trip, average cost per trip, and then emissions as well. So this is where we start to see that the source of energy for your city has an impact on your emissions. So if you use more efficient renewable sources, you're going to see your emissions volume shrink. That's what the cube represents. But also if you use more electric vehicles, that's going to shrink as well. But one of the biggest factors in emissions is really the vehicle population. In places like the United States or Italy, you've got more than one car per person. But in China, you've got 40 cars per people right now. Just imagine if every Chinese person got a car, how disastrous that would be for the environment. So this is the point where you have to decide what kind of future you want to live in. The model isn't just a one-way, it doesn't impose on you what the future will be. You impose on it. It's an interplay between imagination and mathematics. And so it's a tool for designing scenarios. So I'm going to analyze a few scenarios here. This is the 2010 calibration scenario. You can see that most of Singapore has a mix of bus and metro-dependent residents. And then those wealthy areas that I pointed out before where car use happens. And then at the far end here, that's Changi. This is a pretty low-income area. It's very sparsely populated. And there's an airport, which is a major generator of employment. So that's a bit of an anomaly across the island. Now in a hypothetical 2025, where autonomous vehicles have taken over the city and replaced manually driven cars, you can see that there's been quite a lot of change. There's taxi use happening in the suburbs. People are going to start commuting into the city. And we can actually look at the data output from that. So comparing the two scenarios that we've got, 2010 when people responded to this census of population, and our hypothetical 2025, there's a huge increase in taxi use because they're cheaper and more plentiful than they are today. You don't need a driver. Autonomous cars and taxis are going to be a huge business for people in the future. And then we see drops in the use of all the other modes, buses, metros, bikes, and walking too, just because it's so cheap and convenient to get around with vehicles. The average trip time decreases predictably, but the average trip cost increases, and it's an average. So you're going to have some people spending $16 on average per trip, others spending $2 on average, and that's a divided city. So again, you need to ask what kind of city you want to live in. Do you want economic disparity, or do you want a more equal and equitable society? And the annual transport emissions drop slightly. That's probably because the vehicles that we're using are going to be mostly electric. Autonomous vehicles in the future are going to be electric. So it's a slight decrease. The next scenario is, I was playing around with what could I do to make the city more like I want it to be? How can I make it function better? And so it turned out that removing expressways, you can do that in the model by dropping expressway speed down to 0. That has an impact, an enormous one. If you diffuse traffic over local roads, you see that all of the taxi use that we had in the outskirts, that's gone. It's replaced by more sustainable modes like buses and metros. The taxi use is concentrated in the center, and we even see with the completed bike network that Singapore has projected, you see some bike use popping up in various neighborhoods, which is a good indicator. And then here's the data to support this. It's worth noting that the taxi use drops significantly. Metro use is up, bike use is up, and the trip time is interesting. It's increased slightly, still less than we have today. Average trip cost has gone down dramatically, over 30%. So this is encouraging people to be smarter about how they get around. They've got more options and they know that now. So, and the emissions also drop dramatically as you take vehicles off the roads. So the next thing that I did was to zoom in on one specific area at a very high resolution. So this is Bukit Merah. It's adjacent to the city center. And right now there's a lot of residential occupancies here. There's also a lot of industry, particularly the ports along the waterfront here. There's a lot of port activity. And you can see that around the metro stations, there's a concentration of metro use, which is as you would expect. And then in between, people seem to mostly rely on bus transport, which is a positive indicator. Now, in a hypothetical 2030, without expressways and with autonomous vehicles, we see that the patterns change dramatically. There's a lot more of this yellow and red vehicle use. And so there are locations that the model predicts that vehicle dependency is going to emerge where it wasn't before. So I think that it's our duty with this model to counter that narrative of, oh, I need a car to get anywhere. And how can we counter that? By using the existing bus network, which the model predicts people will still rely on bus transport, if you look at that green area. So that's a positive location for a bus corridor. This is some of the existing occupancies in Bukit Merah. You've got hospitals, that sort of thing. What I'm proposing is putting in a bus, putting in these new occupancies, and you end up with different configuration. Here's the data to support it. There's a drop in taxi use. Vehicle time increases slightly, but the trip cost drops. So that's how I'm using the model. If you want to download it, play around with it, this is the link. It's available online. That's all.
Well, Zach, I am absolutely impressed. You know that I like a lot your work and your approach. And for us, it's an honor to have your work. Just one thing, when you have all these device, you can start to put to have scenarios of limit if you want. For me, for example, it would be interesting to have one scenario just trying to have the colors of walk and bike, no, and say what to do to have a scenario practically yellow and I don't know the color, no, and if it's possible to have different spots that are more or less pedestrian, slow city, etc. This was more or less the thing that in Barcelona Vicente tried to do with the autobuses, etc., with the super islas, etc. And here, perhaps you have show different spots with different elements of cars, but perhaps to convert Singapore in a more living city or more, I don't know, human city, it will be interesting to start to move all these parameters and detect the areas where these walk and bike scenarios could be possible. If not, congratulations. I think it's a great project, and thank you very much.
Yes. Thank you also for this very clear, interesting, very serious presentation. Yeah. It's a wonderful tool for city, for urban planner, very important. And I was also very interested by all the history of transportation model from this isochrome to today, and the way in which you explain all your process, the modeling process, the interface, and your application, and at the end, all the development of the scenario. And I would like to ask you, after all your investigation, what does the urban space become when access and mobility is the most important feature in Singapore, for example? Do you have some hypothesis? So I know it's not your subject because you are working on the tools and but you have some elements, and in this way you could have a look on a new book which was just published. The name is Door to Door, Architecture and Automobility, and it was all the innovation of the industry of automobile and all the new programs which emerge in 10 cities in the world.
Impressively focused work and narrowed down. So congratulations for that. I probably got lost in the process, and this might be understandable. I failed to understand if the tool you created can or could in further development, or if this is of your interest or not. You tell me now. But transport behavior is related with the composition of the urban fabric, not only on the distribution of population, or I mean, if the zoning or programmatic mix, density. If you put a hotel on one specific place, everything changes, no? And so, is this tool able to map these subtleties? I mean, is reading from the data of the qualities and the complexity of the existing urban fabric? And if this is the case, can you make the reversal mode? I mean, not only taking from big data of Singapore to model the traffic that this data is producing, but doing it in reverse, being able to, as part of your sliders and controllers, introduce sliders as new sliders, these kind of urban fabric manipulations.
I am also wondering, I really have to commend you on the precision of your work. I am certain that Google will hire you, and you should try to pursue that, or alternatively, start up a nonprofit that fights the secretness of their algorithm as they reroute all of our lives. But I wonder, like Rodrigo, what other levers you can add to this project that point its insights into either more political or more instrumental results, let's say. We know, for instance, at least we have a colleague of ours that's doing a lot of research in Madrid, and she finds out that the location of the sensors for the CO2 readings is a very political, it's a very secretive, and it's a very fluid situation. They move them. They hide them, they move them, they turn them off. So I can imagine that adding, a location parameter to the readings, not considering them as static, it immediately becomes a very political act. And I'm curious, and I wonder if you ask yourself this. I mean, what are the applications? I mean, how political or how instrumental they are in terms of your machine.
Yeah, sure. So to the first question, whether you can create a scenario where it's just walking and biking, what I've done is I've included several preset options inside of this model. You can change to autonomous cars, maybe replacing the trains with travelators, moving sidewalks so that there's no wait time for a train, and even hover chairs. So anything that you can think of, you can modify the parameters to achieve. So I wonder if, yeah, you can definitely increase the speed of walking, and that makes walking so much more attractive. But how do you do that? I guess that you see things like those hoverboards now. So this is something that's on the edge of our consciousness right now, and maybe it'll come to fruition. And yeah, you could definitely identify which areas would be most affected by that. Then as to what does the city become, when you're just focusing on the aspect of mobility. I think that mobility is an enormous factor in determining the function of our city, but not the only one. I think that maybe activity generators, mobility, these things need to come together, and so we can determine what's the optimal way to design a city, because that's not something that anyone's ever done. These cities are usually built up over time, and so it's a trial and error process that creates the optimum for each city. But then in the case of somewhere like Barcelona, where the expansion was designed for the corners, those 45-degree corners that we have, that was for the turning radius of a steam tram. So you can't really let mobility determine your city, because now we've got a harder time for pedestrians crossing the street. So it's a push and pull. There's an interplay there, and I'm not sure where it'll end up. And then, can you manipulate the urban fabric? Absolutely. This city center slider here shows you where the activity generators are less. You can focus on one specific large intervention, like a stadium. Let's say that you want to investigate the traffic patterns during an enormous event like an Olympics or something like that. You can do these changes and visualize the results. And whether it's political, I think, yeah, it's very much a political project, probably more so in terms of economics. And I think that that's a huge determinant in the makeup of our cities. And right now, especially, there's a kind of pushback against the current economic order. And so this is something that it adds a layer of understanding to our cities that we didn't really have before. You've never been able to visualize the probability of people choosing modes of transit before. So it's a visualization of a previously invisible layer of our city. So that's it.
Zach, so thank you. Again, I think we are all very impressed by this connection between the rational analysis about how to make cities and the fact that we can work not exactly making a project, but making a tool that will allow to make projects and to analyze the reality. So we put you in contact with some experts, and I think that you answer very well, they answer well, and at the end you have been able to develop a fantastic application. So I don't know if this is the best app ever done at IAC, but maybe it could be. And obviously it would be great to see how this can apply to other cities and to see what is coming after that. So anyhow, congratulations. This is a fantastic work. Thank you.
Hello, my name is. Hello, my name is Ksenia and I'm from Siberia. My project is called Holistic Archipelago, and I start my research from the theory of the city as archipelago, which responds to the problems of the global urbanization. So more than a half population of the world lives in the city, and mostly all the countries are becoming increasingly urbanized. This phenomenon was caused by the Industrial Revolution, which creates the labor opportunities and the population shift from the rural areas to the cities. But what if there was also another phenomenon? What if the industrialization made people move from the cities to the suburb again? According to the theory of Ram Koolhaas of the city as archipelago and his project of the city captive globe, he explains the urbanization as the simultaneous explosion of human density and invasion of new technologies, which which exceeds the limits of the city as the border. So he calls his project Archipelago, where the grid is the vastity of urbanization and the plots are so-called islands. But what is going to happen if one of these islands is going to be detached? I found an example of such enclave in my own country. It's situated in the west part of the Siberia in Sakha Republic, and the city is called Mirny. So this is division of diamond mining cities. And the history of the city started in 1955 when the group of geologists found the kimberlite pipe and they start creating the city around it. So excavations of the diamonds were made by open pit till 2001, and it created the mine 1 kilometer in diameter and 500 meters depth. So actually, the city was not built like all northern Soviet projects with approved general plan. It was built spontaneously and simultaneously. And here on the zoning map, you can see that it's surrounded by the industrial zoning and the waste facilities where they put the excavation grounds around, and with the airport from another side. So the city population is just 35,000 people, and mostly all of these people are working for extraction of diamonds. All the goods are imported, and is the city with a mono economy. The company which is in charge of extracting diamonds is called Alrosa and is one of the leading companies in the world. So amount of money which is extracted from the city is hilarious, and in comparison of how much does the city got from it, the percentage is very low. So it actually is it's called the diamond capital of the Russia, but as you can see, it doesn't look like. So mostly all the buildings are 2 stories and they're made from wood, and they're built from 1950s. So the quality is very low. Actually, people are living kind of barracks. There is always also problems in the environment pollution. So it's the air pollution from the mine, the soil pollution from the extraction of the soil from it, and the mineralization of water. The conditions of the city are far from being favorable. It's a mono-economy city with a weak infrastructure, with a lack of advanced technologies, as well as sharply continental climate is minus 62 degrees in the winter, and the environmental pollution. So this is the city where is the only source of power, and this is actually extraction of the diamonds. But what is going to happen when the diamonds era is over? What is the next? And there are mainly 2 ways to proceed. So the first one is the exodus to the bigger cities which are already overpopulated and leaving the scar on the surface of the planet with environment pollution. Or there is a second way. The second is the rethinking of the city in order to make it self-sufficient, to change something in the core, to make a favorable conditions for people to live. And I think that we should stop seeing the human presence on the planet Earth as a sort of detrimental to our ecosystem. So we should change this paradigm of just consuming, but also to giving back to the planet. And in order to find the answer to this question, I started from the city morphology. The first step was the Hugh-Barton radius of urban influence, so I divided it by the groups. This administration and business, commerce, domestic services, recreation and tourism, as well as education, cultural leisure, sport, healthcare, and the industrial storage. So all the facilities are mainly centralized. So even the city is growing on another bank of the river, the facilities are not growing with the city. So this is the engineering infrastructure, and even though the city has the huge source of the renewable energy on the north, in 60 kilometers is the hydroelectric station, but the infrastructure is so weak, so mostly all the resources, half of them are lost on the way. So the consumers don't get the entire amount of how they could have. This is the transport infrastructure with the arterial roads, which create the shape of the border, the blocks of the city. And this is the dangerous zones, which are mostly created by the mine. The land slope, but even though they still keep building city on this border without taking care of the mine, not reinforcing it. So as a result, I made a SWOT analysis of the city, which shows that the benefits of the city, the strong point is the energy, resources, and the minerals, as well as the government protection and the help from the government. But the weakness point is the mono economy, the weak infrastructure, the lack of their own products, so they have to import, and the difficulties with the cargo transportation. So my strategy as an answer to that relies on creation of productive grid, which consists of cells 1 kilometer by 1 kilometer. The size was chosen by the 500-meter radius to reduce the walkable radius for the city because it's not that pleasant to walk in minus 60 degrees. So each of these units consists of 6 vital elements, which are energy production, food production, water treatment, mixed use, waste recycle, and the increased density. So in order to analyze the city dynamics, I made the analysis of each of these blocks, the existing one. As you can see, moving toward the mine, the dynamics is growing. So the mine is the attractor point, is the attractor pole of the city. But if we see the mine itself, it's empty. There is nothing happening there. So once it was productive, once it was impressive, now it's just the hole not producing anything. So even the city is distributed around is still have the only one attractor point. So what we should do with the density? In order to find an answer, I analyzed the leading cities of the Siberia. I checked their densities and compare with my city, and actually the nearest city density is 5 times lower. So in order to achieve to increase the density, I don't need to extend the city in the width. I just have to extend it vertically because mostly all the buildings are 2 stories and they're so old, so there is no way to rebuild it. It's easier to demolish it and build another on top. So with the amount of sources I have in the city, and the new density of people, there will be enough source of heating and water. The food is the biggest problem because they're not producing enough even for nowadays population. But the energy will have more energy than we need, because in 50 years the extraction of diamonds will be finished, and the amount of people doesn't need this energy. So why does the city need so much energy? And the answer is on this map. This is the Trans-Siberian Railway and is one of the biggest in the world. So the continuation of this railway is the new road to Amur-Yakutsk main line, and actually to the city Mirny, because the government sees this as the new source of renewable energy. So this is can be a second life of the city to produce energy. But should the energy just considered on the hydroelectric station? And to find this, I did the wind analysis as well as solar analysis. Even the winters are very cold, they're still very sunny, so there is a possibility to get more energy from this. So for this, I use the wind turbine with vertical axis, which are perfect for the speed of the wind existing, and the solar panels on the semiconductor heterostructures, which are made by the Russian scientists who got the Nobel Prize for it, because they are made just from silicon and they are 4 times more efficient. So the waste recycle, I start from recultivation of the existing dumps. So the city is not anymore surrounded by the waste, it's surrounded by the artificial landscape. And in order to make the soil better, to make it productive again, I'm going to use the plant matter to create the high quality compost. And another matter is going to the plasma gasification. For these needs, there is no need to recycle the waste. All the waste is going here and is burned in such a high temperature, so there is almost no emissions to the air. And the outcome is electric power, ethanol, diesel, steam, pipeline gas, as well as coax flags, which can be used in for the facades in order to make the warmer, to make a new material. So the water treatment, consider on the only source of water in the city is the river. So what they did, they make a reservoir and they extracting water through it. But the system is centralized, so it's going only from one source. There is one pump which gives the water to entire city. So there is insufficient carrying capacity, low level of water treatment, and the network deterioration. Where the centralized system will create the autonomy of processes and the better water cycle. The food production, as I said, is very low. So due to the low quality of soil, the agriculture is not going forward. So and they're not developing it. So I took into account the standards for food consumption for this exact space, and I think that the answer to this can be created in vertical farms, which are based on aquaponics and aeroponics, in order to create a perfect amount of food for the people living there. And the last but not the least is the diversity, which I consider consists of residence, facilities, and production, which in merge create the mixed use. So my proposal is to take the current situation of the city, to take the arterial roads as the attractor curves, which create the dynamics and economical dynamics of the city, and increase the density according to them. They implement the productive disposition of the units, and start from wind farm, which is located on one of the dams due to the amount of wind we have there. The solar panels positioned on the roofs and the battery banks, so each unit become energy independent. The reclamation of the dams, the cultivation, the compost polygon, the plasma gasification unit, and the distributed waste separation, so separation on the in general matter and plant matter. The water treatment plant, so each unit has the possibility to have the same amount of water to have it in a better quality. The agriculture fields, existing ones with the greenhouses, and the new vertical farms. All these infrastructures, all these elements will create new places for people to work. But even though there are still some lack of numbers of production of food or an energy, so how to solve this? How to finish this network of self-sufficiency? And I came back because once it was productive in the past, it was the reason why the city was built. What's next to this? What is going to happen there? Can it be efficient in the future? Can it be a real attractor pole in the future? So in order to find the answer, I made a section of the mine, and as you can see here, maybe not that well, but under the permafrost soil, there is a water horizon of artesian basin. And actually this water now is the problem of the city, because they have to, it goes to pollution, it pollutes the air, and they have to protect the underground works from it. But this water, it can be the solution for their answer, because actually this is the sodium chloride water, which is used for balneary resorts, for the health treatment. So in order to use it, I have to create access to it, so the strict access, and for this I have to raise the bottom. So the next step is protect the mine from the slope. For this I use the diamond grid structure, and which will cover it, and from the left side, and the second part is the recultivation of the mine. So from one step, the soil, the roots of these plants will protect the soil. It will make it more stable. And from another part is it will create the new air, new microclimate inside the mine. So the next step is the infrastructure grid, the transport via bridges. These roads are a continuation of the roads of the city, but across the mine. But what's happening next? So the answer of the global urbanization will be the high rise. But how this can be implemented in this specific area? So should it go above the mine, the buildings, or should they go through? And the answer is through. So these earth scrapers are in self the microproductive units, which extract the water from the bottom and pump them to the up. So in the structure is the upper level is the transport access through the ramp from the road to the tower, the vertical connection core, and the twisted structure which have the LED light greenhouses inside, and the continuation of the structure is the water supply pipes. So the next step is the vertical division and the curtain wall from the glass covered with exoskeleton to make to make the construction more stable. And the last part is the outer reinforcement structure, which is rotated in a different way in order to make it more stable. And this structure is made from photovoltaic transparent glass in order to create the amount of energy needed for these towers. So this is the cultivation of the water inside. Is the extraction of the water then goes through these pipes which have filters inside. It will go to the water management where it's moved forward to the upper part, and they're distributed by these by the structures inside with the greenhouses, and the waste of water is disposed by these greenhouses. So this is the cycle of waste. It's separated to the bio, which comes back to the tower as a compost for the greenhouses, and other is exported to the city, to the plasma gasification station. So this is the wind angle optimization in order to create better ventilation. The windows are located in a certain angle to have the better airflow inside. This is the inside structure of the city, or of the building. So there are four main elements: the vertical community, which consists of residential, administration, business, education, culture, leisure, domestic services, and commercial, as well as food production, which light green, which goes through the structure in the upper part of the structure, which has vertical farming, food storage, LED-like greenhouses. It distributes the food along the tower, and it also absorbs the CO2 emissions. So water management located in the water pump. In the water part is the water storage, the pump, the water treatment, and the separation to the vertical community and balneary resort. And the last balneary resort is the way to use this chloride sodium water in a better way, to have to create the healthcare facilities, the sport facilities, and recreation and tourism. These all four elements are working all together, so they are merged. They're not divided by the slabs, but they're all connected through the main core. So this is the view from pedestrian view from the new grid, from the new roads. So this new topology created by the new infrastructure grid. And as you can see here, the heritage is not touched. So we can see the impressiveness of the mine, how it was. It's not hidden by the cover. And this is the top view, where you can see that the buildings are not attached to the border, so they're not affecting the permafrost condition of the soil. And these micro units, actually, they are creating macro unit by itself, and this macro unit is filling the gap of this self-sufficient network. So this gives the possibility for the city, for the new city, to have a future as a city archipelago. Thank you very much.
Thank you. First of all, thank you for traveling us into a pretty cool, like really literally cool space. I think it's, like the other day we had the conference of Xavier de Castellet, that he was showing how he's 3D printing in the moon or in the Mars, and there are so many people trying to work out on how to build on that extreme conditions, even extraterrestrial. But I believe that there are so many places on the Earth that they have this kind of possibilities, and we need to stay in Earth. So I like very much the fact that you're getting us into that a very, very special site. I find all your analyses pretty interesting in terms of what was the existing scenario of generating economy, but also how the city was functioning in different levels. And I do like the proposal, but I am missing to understand how all this complexity of the previous urban fabric is also present here. So it's very radical that you're placing those kind of residential / infrastructural units inside the mine. I don't have the knowledge to know whereas the conditions, let's say, what kind of contamination or what kind of issues you will have inside the mine. I'm not sure about it, but I think that it's interesting to see how instead of creating this kind of independent cocoons, like you're really trying to connect it in a more lively way, not just by lines of connections of mobility, but really also connecting them programmatically, or connecting them like in a kind of proposing new social interactions, right? So when you are proposing of bringing food back there, how can these be connected with the rest of the city, or how can it bring residents, or how it can interchange people, how your energy generation could also be given back to the city next to the mine, no? So how those independent cocoons are also a kind of an attractor of social activity, of economical activity, and really not be seen as individual things, but really connected with the site. I think that would be very interesting. And in order to do that, I guess that you need to get a bit deeper on how it functions, no? It's not food just for the residents, or it's not services just for the people that they are living there, but it's really something that is adding to the existing levels of the urbanity. And yeah, I mean, it's a very nice work. It opens up like a lot of discussion on how such infrastructures could be applied in extreme conditions.
Thank you for this yes, very interesting project. And I'm also very interested by this amazing site, a new industrial city, if we could say that. And also, I really like this project because it's a project, again, obsolescence. And as you said, in 50 years, the extraction of diamonds will be finished, and what happened? And you are in a very prospective way, and you question this issue of obsolescence of our modernity excavation site, and it's very emblematic of this problematic. It's also an injunction to recycle and to transform our landscape, which was damaged by this industrial excavation in relation to the ground, to this Anthropocene period. And I would like to ask you, how do you consider the relationship to this ring? How do you consider the relationship to the ring, like this landscape ring? I don't know if you know this sentence or this concept of Louis Kahn about the wrapping ring around building and the link with between architecture and the ring, and how did you, if you have some elements on this point, on this relationship, and okay, and I really appreciate this work. Thank you.
Thank you very much. Xenia, thank you. I was always interested in this subject and in this context, very, very hard, because it was very interesting for the agenda of urban recycle, that it's one of the agendas of that are here in the YAG. No? This idea to reactivate the reality with new layers of information. The idea of reinformation is a word of Vicente. And I don't know. Your answer is your answer. Is this? I think it's very well expressed. The sophistication of the representation, the sophistication of the analysis is very well. You have a infrastructural answer, if you want, a new layer of infrastructure that is reactivating the real space. Just a little thing, because I think it's a good project, to be sincere, but is, in other terms, the analysis of the urban morphology and the layers. The layers that you use are layers of functionality. They are very traditional, and you use it. I start with monograph. If you use other layers of, for example, tourism attraction, you have other kind of topics. For example, sensual atmospheres, patrimonial landscapes, strange attractors, paths, etc. That can perhaps could be interested to have other kind of layers to be reactivate in the holistic urban scale. You have an approach with infrastructural and ecological, to say, no, my city is a super eco city, no? And it's a radical point of view. I say, is your answer? Perhaps my answer will be, my city now is a new dream city, no? I don't know. And it will be another kind of answer. But I am interested in this because the capacity to go to a situation with a limit, a city who is productive, who is not, in theory, very well attracted, very attracted. And with this enormous event, because this is an event, but I think that is unique in Russia, perhaps there's not a lot of this scale. I don't know if this city introduced the eco layer, the energy layer, no? With other kind of layers, with the capacity to have, I don't know, strange landscapes, perhaps some patrimonial elements, this event, etc. You can use it as a how to say, a new integrated system, and perhaps you don't need all these paraphernalia that you use, and this is a family of because also Diego and in the history Edgar has this kind of approach, a very cocoon energy. I don't know. I am not so convinced, but I think it's a very serious for you and absolutely what's his name, very well expressed. And for this intensity, congratulations.
Thank you.
I'll be super fast. You know, when you are making the environmental analysis, for example, the radiation analysis, was precisely this hole the most interesting part. It was at least the north side of the hole that was receiving all the radiation from the south. And I'm sure in terms of wind, it happens the same. I'm sure as lower as you go, it has more thermal inertia, and as higher, it has less thermal inertia, so more fluctuations. In fact, these terraced holes are used in some countries of Latin America for cultivation because they can control the climate as well as the water movement. So what I mean is that if you analyze just of this spot and you inform with these crazy structures, you will get to some even more surprising results. Just informing the design with the environmental analysis of this unbelievable structure.
Yeah, I think so. I'm sitting next to Rodrigo, so I'm agreeing with him all afternoon. But I'm going to be really quick. I think when you use Kulas, that was the wrong case study. The right case study would have been Fuller again in Manhattan, where he makes a dome which covers the entire Lower East Midtown. I forget what it was. I think it was a mile, and he calculates, or 2 miles in diameter, and he calculates the thermal mass. And he says that just by isolating that amount of air, it has its own thermal mass properties. And then he calculates the amount of snow removal, all the energy that goes into maintaining the grid of Manhattan now without getting snow, without getting wind, without getting thermal. So I would look at that case study and imagine this as a thermal mass opportunity, right? The vastness of the space and the section working together with your thermal analysis. Absolutely.
Just the last thing, I come from the mountains, so I'm flabbergasted by this negative mountain here. In some way, I think it's a very beautiful project, but I suggest you that you only not work in the middle, but the edge of the mountain. In the same way, when you have a positive mountain that we climb through the mountain and we use that surface, okay, we do tunnels. In your case, it's all about tunneling, going through this emptiness. And somehow you've forgotten about this surface that as well has some potential. Other than that, I think it's a beautiful project.
Okay, thank you very much for your comments. I like them, and I was keeping in mind this the influence of the environment, of course, but I think that this is the possibility for further development, to have this, to change it so it is like uses as a base. So, and as well the tourist program and everything, this for me is like a future step, because I took these 6 elements because they're crucial for the city. If I don't change this, the city won't exist anymore. So this is like the first step for the city to have their future life, because you're totally right, it has the planned obsolescence of the city. So as a further development, the connection of the city with this, because actually this unit was created to connect the city with the lack of the food or lack of the energy. So the connection probably can be like stronger, and as a further step. So yes, thank you very much. I totally agree with your comments, and I I think this is a good proposal for the first development of the project.
So, just to conclude, I would like to say that, yeah, I like very much your expression about the fact that before than any kind of incredible performance for this whole. We need to transform the city. The idea that you really has been looking for some rational approach about transforming the city. In fact, connecting very much with the master on city and technology, in the same way some other people did, trying to understand the different layers and how to regenerate your city. I think that this is, I mean, I think is very well done. At some point, your presentation, I was lost by the Venetian and the Moscow effect with this kind of calamari system. But at the end, I think that this image is pretty very good. So I think it's better than not the analysis on the constructions itself. That it's very strange in your presentation that you have been like realistic, very, very, very realistic in the 90% of your presentation, and at the end you have the 10% of Maya, Rhino, whatever system. What is strange. Anyhow, I think that is as a suggestive image for the idea that this is a place where you can create a future that where we should try to put as much as interest on building such a structures as they put the interest on destroying the rock and making a hole. I think that is very suggestive, and I promise that I will visit your city at some point. Thank you.
Thank you very much.
Hello, my name is Sandra, and I'm from Russia. My project is a proposal of creating sustainable living communities based on the ex-Soviet districts built after the 1960s under the Soviet ideology. I will tell a little bit of history before in order to explain this phenomenon better. So before the revolution of 1917, which was the start of the Soviet Union, when Russia was under the Tsarist regime, 40% of the population of Moscow used to live in revenue houses, which were privately owned buildings, and people were renting tiny apartments there. And it was expected that they will spend more time outside. When the Bolsheviks came into power, they confiscated all the private-owned buildings, and people had to start sharing commune apartments and barracks. So that meant that each family had their own room, and the kitchens and bathrooms were shared. In 1955, Nikita Khrushchev came into power, and he started a massive building campaign. His dream was to build individual dwelling for each family. And this was the start of prefabricated housing in Moscow and later in the whole country. These buildings were later called Khrushchevka. They were 5-story buildings because more than 5-story buildings were not allowed to go without elevators. They were fully made of prefabricated elements. And this prototype of massive prefabricated building could be with different modifications implemented in the whole country. In Moscow, the neighborhoods that are generated with these buildings are in the outskirts, and the relation between the periphery and the center of Moscow is very different. And I have to say that all the attraction points and most of the offices and educational departments are in the center, so the city is very centralized. And with my project, I'm aiming to decentralize the city. Right now, the dwelling that is getting built in Russia has much better conditions than in the Soviet times, but the dwelling system is the same. So people have private apartments, they live in sleeping districts, and every day they go to the center to work. These are different districts in different cities of Russia that have very different conditions, and they all look very, very similar. And this is the situation in Moscow, which is the same. I watched some movies in order to understand how people see these Soviet districts during time, and in the beginning, cinematography shows us happy people getting their own apartments, and right now these districts are shown as places for violence and not the best place to live in. And here we can see how these kind of districts were changing through time. So at first it looks really good, but then now it's getting worse and worse. This happens because of the ideals and the regime that is in the country. If the socialist ideas were work, culture, and social activity, and the districts were built to fit these ideals and to be comfortable for being socially active, but not considering the individuality of people. And then now people tend to be more individually free, but they sometimes forget to be socially active, especially in their own neighborhoods. But now the architecture is considering the fundamental human needs. As my case study, I decided to take Kapotna district. It is considered the worst district in Moscow by the Russian statistics company. These are some photos of the district. So you can see that it's really bad maintained. It has bad ecology because of factories around. And this is the existing plan. So we can see that on one side it's bordered by a highway, which is the fourth ring road of Moscow. On the top there is an oil refinery, and there is a really big amount of abandoned garages and houses and warehouses. I highlighted the problems of the Soviet neighborhoods right now. They are illegal extension, bad maintenance of structure, and illegal privatization of public space. I propose to renovate and make the Khrushchevka buildings comfortable for a sustainable way of life and preserve culturally meaningful buildings, and to make a green border from the highway and the factory. I researched on some trees that could be planted there. So these are, the first line is year-round trees, which will be green in the winter. The second line is trees that are cleaning from metals that are produced by cars. And the last one is trees that are only in the summer and they are holding the dust with their leaves.
This is how I'm increasing the green zone. This is my proposal for the parking system. So it is to build underground parkings, because the above ground parkings are inside the each micro neighborhood, and they take space that could be used for social activity. And I'm increasing the facilities and the social infrastructure in order to make it a better space for living. And to do that, I'm dividing the district to blocks, which will have different facilities such as shared outdoor kitchens, urban greenhouses, workshop and lecture spaces, and libraries. This is one of the blocks that has all these facilities. And also, I'm diversifying the housing with adding dacha type houses, which are like country type houses. I will talk about it later. This is how the housing is increased. In order to make sustainability work in a ex-Soviet neighborhood, I made this operator diagram. So the operator will provide facilities, services, management, and resources to the neighborhood, and the operator can be either a private company or a municipal one, or and so to make that work, there should be, like, each family has different needs, and they will be able to choose facilities and services that they want to use, and the operator will provide the payment system for them. Also, in order to make people live in a more sustainable way, I made this diagram, and we can see that sustainability will be more efficient for the operator and for the residents. This is how the building will be renovated. The buildings will be renovated. So I'm adding a layer. I'm extending the building, and there will be a kind of cover that will make it warmer in the winter, because these buildings were very cheap and the walls are kind of cold. Also, I'm adding use to the roof, and the first floors will be used as classrooms and lecture rooms for different uses, and people will be able to choose if they will have a food garden or on their balcony or no. I made this analysis in order to understand on which side of the building we can plant. And now about the dacha houses that will be also in the neighborhood. Dachas are country-type houses that are not far from the city. In the Soviet times, they were given as a gift to people that are doing socialist things, and but now they're used by urban dwellers, and it is said that 15% of the vegetables in Russia are grown by urban dwellers in dacha farms. This is how the urban farming will be distributed. So it will be on the roofs, and it will be in separate greenhouses. These are the possibilities for planting. So these are plants that can be planted in these climatic conditions.
And this is the sustainability in summertime. So there will be the garden on the roof. There will be water storage and recycling, waste management, and methane production. And this is how it will work in the winter. So in the winter, there will be added a foldable greenhouse structure on the roof, which is like an origami structure, and it will work as a rainwater collector and will be also used for irrigating plants and toilet flushing. The methane produced will be also used for heating. And yeah, that's it. I think that for now in Moscow, total sustainability is not very possible. But I think that it could be a good step, and the ex-Soviet neighborhoods are a really good platform to make people more social. Thank you.
Sandra, I think that you have a known universe, very particular and very interesting, when you express all your research and ideas with your particular way of representation, drawings, collage, all these things. It's very continue with this because it's very sensitive, very poetical, and very beautiful. Also, you're in the sense of Xenia, but in your particular, it's a very strange thing, very difficult between naive poesy and rigor. And this is very interesting to continue there. For the project, I think that the analysis was very interesting, also in theoretical terms, with the relations with the evolutionary timelines and the idea of the city of Moscow, etc. I think that it's a very interesting project of reciting, no, or recycle in all the terms, renaturalization, reactivation, and why not, re-pushing in economical terms. Perhaps we remain with, we need to understand more that this section, no, because for the buildings, well, for the urban spaces, it's clear. I think it was very beautiful. Also, the reconversion of some public spaces in agro spaces or in relational spaces, etc. For the existing blocks, you have this section. I don't know. Perhaps we need to know more about the challenges, the performances, the different capacities of variation in these strong blocks that now can be a kind of mixed element, etc. No? And this is the only thing that it will be good to have more about this concretion of the capacity to go from this actual situation to the future. No? Perhaps with not today and in the future, or something of this kind of formats of different steps, different phases, etc., etc. No? But thank you very much, and continue with your own universe. What do you think?
Thank you. Thank you for the presentation on this very interesting subject, how to transform this mass housing habitation, and in this Russian context, in this city. Here again is the issue of transformation, recycle, and it's again an injunction to transform the city in its whole, what exists, and I'm very sensitive about this question. I like also because you are not in a futurist approach in your design, it's very pragmatic, very real intervention. But also my question will be, here the question is about opening alternatives between demolition, rehabilitation, restoration, I don't know, or preservation, and how create the good scenario, the one which could be the most adapt to the future of this site. But yes, I would like to have a little bit more about the construction process, or what things change really from the point of view of materials and know-how, economy of means, recycling, and how also the models of the Soviet housing evolves. What did you keep something which is important for you, or how did you know?
Yes, I can. Should I answer now?
What are you keeping?
I think you chose a super critical topic, and it's very important to have answers for this. This is happening all over the world. Actually, we have some neighborhoods close to Forum that they are doing the same thing. They have the same illness, they have the same problems, and they are trying to solve the same thing. We have architects working all over the world on that. So it's a serious issue. And this seriousness is somehow contrasting with the kind of naivety that you saw, for example, in this section. All over the world, what they are trying to do is to inject density, because the problem of these neighborhoods is the lack of density. Programmatic density, that you kind of tackle it, but also just standard density, normal density, built density. And that's why it's weird when you attack this issue of the density just with some small dachas, you call it, dacha house, or even building underground, moving the parkings underground, and not taking the opportunity of, okay, take this image of the dacha house, take this other image of the section, and try to, as brutally as you can, forgetting the poetry, as brutally as you can, give the qualities and the flexibilities and the fertility that has the dacha house and the orchards around. Give to this image of the dacha house the brutality that has the 70s and the 60s building, and combine it. Make a hybrid between these two images.
Thank you. Just very quickly, I was very interested in your initial slides where you basically associate typology with a regime, no? At the very, very beginning. I mean, you don't have to go back to those, but I wonder if rather than you decided to take the right rather than starting from scratch, actually you stayed mostly with what is there, and you were very respectful and cautious. But I wonder if in those initial slides you can speculate. So not stay with Putin, but keep going and speculate on both sides, right? Speculate about the relationship between the typology and the regime in both directions. What regime produces what typology, and then what typology produces what regime. And speculate to the next one. And I'm sure that from what you've learned from upgrading the context, it will be, it will open up lines of research.
Again, I agree with Rodrigo. No, I think you've tapped into a great issue. Unlike the automobile, which we all know that at the end it's derelict and you have to spare it away, housing or existing housing in the world is going to be there for a while, long time, even longer than its expected life. So it is an issue. Though instead of naivety, I would say that there is a lack of energy here in you trying to give solutions to this big problem. You've only managed to put up or very few possibilities to address. I think by looking at your work, you could have come here with 10 different solutions or 20 or 100 solutions that can be applied to different situations, different orientations, different cities. I don't know. I feel you can give a lot more.
Thank you. Well, there was only one question, actually. It was, what am I keeping in the neighborhood from the Soviets? Well, the space is organized in a kind of the same way. So there are spaces for social interaction that were kind of ruined by the capitalist regime. So like little kiosks were added, outside, and so now I was trying to keep it and even increase it. And all the other comments were very useful. Thank you.
So my last comment, sorry, my last comment. No, I think that, again, the subject that you choose is very important. We talk a lot about this, but Rodrigo used the word ingenuity, because I think that you really start to work on the project, no? And I see that the approach that you have, in fact, doesn't recognize very well the fact that we are in Russia, that this was the first neighborhood developed somehow for this worker area, etc. And we will be expecting more radical and more deeper proposals from your side, no? I think that the bad news is that we saw so many other presentations that in the last 3 months they worked really a lot, and in your case was not like this, no? So I don't know, I think that you have still some time to present your final thesis, but I think you should really work harder in order at least to approach to the level of the work of your friends. The subject, again, is very well chosen. The place is incredible, but in order to follow or to fulfill the level that other people did, I think you should try to work a little bit harder from here to your, let's say, final delivery in September for your final report. Anyhow, I think, again, I saw very beautiful drawings. This is a beautiful drawing. You start to do a good project, and what is a pity is just to start to do a project and not to make a project as we like to do here at the ACT. In any case, thank you for your work.
Hi, I'm Rosanna, and I'm come from Angola, and I'm going to give you like a short little 2-minute clip into understanding what it is to live and understand what the city's all about in Luanda.
The 14th century becomes a common cause. Oppression, discrimination, and precarious circumstances unite them against a common enemy. Thus, modern nationalism is born. By 1961, diplomatic efforts to convince the Portuguese government to grant independence are exhausted, and a call to arms is headed by the population, a conflict that would last 14 long years. Dr. Agostinho Neto declared Angola independent on November 11, 1975. But with the death of President Neto, the war takes a turn for the worst. This turned Angola into the last theater of the Cold War. The war stops and the first elections are held. Although they are considered free and fair by the UN, they are rejected by UNITA. Thus, the war starts anew, although this time it is more fierce and violent and thousands of people die. It isn't until April 22nd, 2002 that peace is restored.
Welcome to Luanda, the most expensive capital in the world. According to the prestigious Mercer's annual survey on the cost of living, Luanda topped the list ahead of Moscow and Tokyo. It is the world's second largest producer behind Nigeria. The city of Luanda, the capital of Angola, feels a bit like a big building site. A decade of peace after a 30 years war is transforming the city forever.
Luanda is experiencing a deep transformation right now. During the war, many infrastructures were severely damaged. Roads, bridges, and buildings needed to be redone. In addition to that, we are replacing the old sewage, gas, and electricity systems to be able to respond to the demands of the wave of new buildings. We're also working on a new train network, a new airport, and building houses to relocate people in favelas.
All the new infrastructure and modernization hasn't solved the problem of the city's social inequality and poverty.
We don't have health enough, the access to water, the access to electricity.
I think it's necessary, after 26 years of war, that we engage in some serious reflection.
Sorry, it's all the way in reverse. Right, so my main interest is basically with regards to informal cities, because there's a tendency to want to displace the people who are the poor people to other regions, and what really happens is these people end up selling their property that has been given to them, and they go back to the same slums. So it kind of states the fact that people enjoy where they already live. So it's kind of like, why don't we improve the existing slums or developments? So just to kind of step back a little bit, the name of the project is called Hydra Kianda. Kianda is a local word in the native language of Kimbundu, and it embodies all things related to Luanda's kind of coast. For that reason, it's being used in the project's name. So Luanda is the capital of Angola with a population of over 2 million inhabitants. Cabo Island is a coastal region where the project is situated. The research addresses the topic of informality through informal settlements. They are residential areas which lack the basic necessities, whether it's in Angola or whether it's elsewhere in the world. It's a growing phenomenon in all the corners of the globe. And so basically slums are a real problem, and it should be addressed due to its positioning in the center of the cities. So like most slums around the world, the unpleasant aesthetic in Luanda is no different. However, where there are new constructions, a poor disadvantaged neighborhood is situated close by. One of the main necessities in these slum areas is the access to water, but this is also the case for the majority of the city of Luanda. The causes for the emergence of the informal settlements in Angola are rooted in the civil war that took place and population growth. So people basically uprooted themselves and into whatever uncharted territory and that was available, and they basically included rich, luxurious places. So you end up having a beautiful territory with slums in the middle because they were vacant, and so they just occupied them. So when you are on this coast, you encounter poorer neighborhoods, but also the touristic kind of restaurants and nightclubs. And the tourist dining attractions are placed on the edge, which kind of hides the slums on the inside. So up until the 1960s, Luanda had a very steady development and courtesy of the Portuguese colonial rule. And as aforementioned, the outbreak of the political instability and the war in the country caused the emergence of the slums, mostly people fleeing from the rural areas into the city. So currently there are actually no maps which kind of show what these informal territories look like. So I kind of had to kind of draw it out, understand what they look like and how they position on a territory. And it's kind of self-explanatory how chaotic they are. So these are basically the tourist attractions which kind of frame the regions which have the slums. And it's quite glamorous, as you can tell. So Luanda's one of the main issues in this slide is also distance as well. It's relatively small, but the only way you can actually access the places is really through cars. And the idea of walking is actually quite unpleasant. So it's something that I wanted to kind of explore. And also to kind of add to that point is the fact that there's a waterfront development which was in the Pink region, and basically it was a very expensive investment, but they didn't really consider the contextual, cultural kind of environment. And I think it's probably kind of important to kind of merge the two together in some ways, in a way that you're able to kind of create opportunities for those who are in slightly poor regions, and kind of even use the more glamorous setup of the region. So Luanda sits on a relatively flat land, where the highest point is at 9.1 meters. And so its low elevation and high moisture kind of indicate or hint at the fact that the precipitation doesn't really fall onto the territory. So you kind of end up having a lot of fog and a lot of atmosphere moisture in the environment, which doesn't really come down. Traditional Luanda architecturally also kind of implies acknowledging colonial Portuguese style, which during the 1930s referenced the international style. But in the 21st century, circa 2007, Luanda is known as has become known as a building site. But it doesn't necessarily have the kind of interconnected urbanism that relates to the cultural context. So the research kind of urges and acknowledges the reality of the slums in an attempt to design an adequate and appropriate environment, producing a kind of agronomical landscape consequent of the provision of water, a system where water is the operator. And in order to provide such a system, it's crucial to kind of assess the energy consumption so that the type of system can be outlined. Luanda struggles with a centralized system which indicates the necessity of having a decentralized off-grid energy kind of supply system. And this can be beneficial if it's approached in a way that kind of minimizes the ecological footprint. So in an informal settlement, there are 4 main areas that should be addressed in order to improve the settlement. The design objective is to design a suitable water supply system for the informal territory in question. So that's what I'm intending to kind of propose. Fog harvesting farming is basically the collection of water from the fog using a vertical mesh canvas to make the fog condense into droplets of water. And Luanda has very tightly pressed vapors, which I mentioned earlier, which is unable to condense into liquid, so which makes it kind of ideal for the kind of water sourcing. It's clear that over 4,000 liters of water may be produced in a day, depending on the surface area of the mesh, and its application is a relatively simple procedure. The idea is to implement the system in the vacant spaces, the in-between places of the territories. So it's quite surprising, actually. I wasn't expecting to find such open spaces in between these kind of self-imposed structures. So in this system, water then becomes the main operator, but mobility or pedestrian circulation becomes a part to kind of aid in closing the distances and making things more walkable. And the proximity is also addressed by the closeness of the given facilities, enabling people to walk comfortably. It's an important measure that addresses circulation in the region, and I think it will help to make the region more vibrant and actually become more diverse. it's important to note that the micro level in the context of the research project is the main issue of water, or the need for water, that will be addressed with a series of change events that kind of follow from that. So the average kilowatt hours per day for a regular household tends to be, around 10 to 20 watts, depending on the size of the household. So in Rwanda, you have the opportunity where you have 81.6 watts per 100 square meters, which kind of means that you get like 816 watts per 1 meter, which is a lot of energy. So it's also another way to maximize and use it to add to the system, I guess you could say. And because it's a coastal habitat, the wind analysis kind of ensures the rate of movement for atmospheric moisture to be captured by the fog collector, where the average speed is about 3.5 meters squared, which actually is not very much wind, but again, as you kind of have these, I can imagine, kind of tower, the higher it is and the easier it is for the moisture to kind of get into the structures and become collected. So I start with, this is the site territory. It's about a stretch of 1 kilometer. The next point was to kind of illustrate the spaces in between. Then I started to kind of create the spaces, the what kind of facilities was required to kind of help the neighborhood, I guess you can say, and becoming more useful, what kind of facilities you need, and the spacing in between them. I thought that was important to kind of outline. So starting with the playgrounds, and that's about 250 meters in between, so it's like a 5-minute walk. So it's easy for children to kind of walk through and get to the places. And then the next point, you add on the next layer, the primary school, the old age center, the kids center, and it's a little bit further away, but it's, kind of break it down into little regions. And then you have the car park, the secondary school, and so forth. So what was also quite, so once you kind of establish these different points, you have this is what you can say, where inside the box is basically kind of the highest territory in the region. So I wanted to use that to my advantage and position these fog collectors onto the region so that you can maximize the water collection. And so just to kind of illustrate how they would be positioned, you have the solar power, and this is where the solar power pumps become useful, because with collecting the water, you want to also distribute it around the region. So solar pumping became a method to use it, which is ecological and not having to have mechanical power to distribute the water through the region. And this is just to kind of point out, I guess, how then the surface pipes, which are then going into the regions, are kind of connected or kind of end up highlighting the pedestrian kind of movement. So this is just the occupancy spaces. And essentially, this kind of rule, because it's such a long stretch, I would apply it within every 1 kilometer or so that it kind of repeats itself, and then the facilities are doubled over time. And also, once you kind of get inside it, once you kind of create these accesses in between the spaces, you're also creating an opportunity for other kind of building spaces to kind of emerge, and and then actually investors and designers can then start thinking about designing new projects on the inside, because you're highlighting these points. So this is the actual structure itself. It's not very big. It's actually, I think, as I mentioned in the previous slides, is the surface area of the mesh, which is the box thing on top, is about 1 square meter. And basically, it's quite high up. And what I did was I adapted it to having a bit a longer height, I guess you can say, so that it can reach up high into the atmosphere. And then the biggest structure on the side is the solar pumping infrastructure. This is just the plan. So just to show you how small this water collection device really is. And also, what was also quite important as well, just to kind of mention, is where you have the outlet points, which is somewhere around here. It's kind of a little bit above the human kind of height, so that you end up having these distribution pipes above head height. And so that's just to kind of illustrate what I'm trying to say, really. And also, I forgot to mention, but on the plans beforehand, if you kind of go back a little bit, the fog collectors have been positioned within these urban farms, where the food production of certain plants and fruits and vegetables to help contribute to the local economy. And so yes, and then this is how how the fog collectors are integrated in the urban environment. You have the pipes, which kind of highlights the public space. And ultimately, the idea is to have a system where the water is the input, and then it kind of comes back full cycle back into the territory, hydrating the region or hydrating even the urban farms. And so you end up having a stronger ecosystem over the years. And so this is just to illustrate I guess you say the habitat phasing. So once you kind of implement this environment, then it should flourish over the years. And essentially, working with slums kind of implies going back to basics, because they don't have certain facilities, and so you kind of need to reassess what is the important aspect of a small neighborhood for a certain number of people. In this case, about 20,000 people. And how many facilities kind of are in the region, and then ultimately I guess it will transform the coastal habitat, because the tendency is to have very touristic kind of hotels and things like that, but then at the same time, at the core of a city, there are also poor people and there are rich people, so we have to kind of accommodate for all of them, and instead of trying to bring them away from what was always their home. And with that, I finish. So thank you for listening. My apologies, sorry for the video. The sound quality was quite low. I'm not sure
so we're going to start on this side now, but just very quickly, as you continue to develop, and it's a little bit of the question that arises when you're dealing with informal settlements, the degree to which formal versus informal is balanced. You showed a number of layered systems, of which, by the way, the fog collector, I know a number of groups in the US that are trying to really develop this technology, which is extraordinary. And you wonder, each time you add one of these systems, I keep thinking of the ratio between the formal, the informal. I keep thinking of how you affect. Each of them are revolutionary in themselves. How does it really begin to affect the entire organization and start from scratch, start from new, be more efficient, transform it? So I would, if I were you, scrutinize each of the layered systems that you have outlined and go one by one, prioritizing them, and then demonstrating or even asking yourself, how are they transformative?
Thank you.
Just one question. What's your position on gentrification? I mean, how do you? It's like you propose. There is a text very short by Rainer Banham. He says that take a boat, a standard boat, put him an outboard motor, and it's an outboard boat. But I think in cities it doesn't happen that easy. I mean, you put these little machines, these little devices that give energy, food, social interaction, and suddenly the neighborhood starts to change. I mean, it's like you showed us the picture of when I put this in 5 years will look like that. But how do you imagine the situation in after you did this in 50 years? What happens after 50 years? How densities increase with the increase of value of the land, for example?
Thank you for this presentation. I think that you analyze at the urban scale and your global vision of all the organization of the city is very good, very interesting. You go back to the fundamentals, resource and organization of mains and pipes and these fundamental needs to develop a good urbanity and a possibility to live in a city. But your micro archi infrastructure, I think it could be more, probably a little bit better in the formal development. Or if you go back to your picture, I encourage you to try to, yes, to develop a little bit this, yes, like this, okay, yes, change everything. Yes, to work a little bit more on this micro infrastructure in a more formal way and little bit aesthetic also technique could be, you know, in this approach.
I'm not sure I quite understand, sorry.
I think that all the global analysis of the urban scale is very good, but when we go back to the small scale, your small infrastructure, which is implanted at different points of your site, we have this tram, the tram. We don't know exactly what are inside or at the scale of the building, the form of this object.
Okay.
I think it could be really better.
Okay.
I think that what Fanny is asking is a bit more sophistication into the design of the devices. And I would agree if you take that way, but I see two ways. So I like very much the idea of getting into this kind of informal settlements and try to change them with very small acupuncture, let's say, movements, no? Small scale, different of them, a mix of them, not very big impact in terms of the landscape, not very big impact in terms of performance. I mean, I doubt that the pipe thing is as you're talking about, but I think that those stations, like those actions, could be much more, let's say, light in terms of how you place them and have a big impact. And this is one way which I think that it is a very good way to deal with when you are at the informal settlements. But then I would ask you, build it. You know, you should have been here today with a big prototype, either there or somewhere in the neighborhood of Barcelona. So one way is that way of really making the actions and small scale things, like really changing the urban scale. The second way is understanding and getting deeper into those different actions, and then you need to be more sophisticated into the design aspect. You need to be more sophisticated into the selection of materiality of how this is being happening. You need to be much more sophisticated in terms of what is the impact in terms of numbers and statistics to understand what would be the impact on the urban scale, what would be the impact on the social aspect, no? So I see those two ways, and I see you somewhere in the middle. And I would ask you to take that decision and go for it, you know, and maybe you're closer to the first one. But then we have all these laboratories, just build the prototype, you know?
Rosanna, sorry, because I had and I lost part of your presentation, but at the beginning, I know some things about your project, and always was very interesting this reflection about the slums. As now, Angelo will present, and it's in the same line, and also the bottom-up occupation, the self-organization occupation. In this kind of settlement, as you have said, you have there are space-time dynamic deployments, and you have points of occupation, uh, voice, voids or empty space of separation, and lines of paths. You have points, surfaces, and lines. The points are occupations, the surfaces are separations or distancements, and the lines are paths or connective connections. In your case, it was very clear at the beginning this idea that to work with the voids, when you have dynamic systems as the fish elements or that, these are dynamics. They are always elastic. No, all these things are changing. In the settlements, there are dynamics, but you have a little stability, and you can work with this. No, and as you have discovered, this is interesting. This idea to work with the empty spaces, with the voids, to activate or reactivate these settlements. I think that you have two possibilities, or working with acupuntura or working with meshpuntura. I don't know what to explain. The acupuntura, it's the tradition of the 90s, and also with the idea to have to detect spots, detect spaces that are voids, and to activate it. I am closer to work with these spaces and with the lines, trying to construct new networks, networks of voids and connections that are a new kind of integrated spaces of public spaces. No? This is the mesh puntura. No? I don't know, because when I see it, but perhaps I lost something. Sorry if this. I think that your idea is more to attack the void spaces. Perhaps if you connect these void spaces in a kind of network and you push there programs and activities, you have this idea of active public spaces, working with the idea of network and working with the idea of network of intelligence, not only network of physical connections, but also network of. But at the same time, just for personal tal, I think that your research is very serious. You are very serious. Congratulations for all the theoretical aspects of your research, and thank you very much.
Well, thank you for the comments. Very, very, very useful. When it comes to when it comes to how are they, I like the fact that trying to understand how something is transformative. I think that would definitely be the next one. How does this actually change the environment? I think that would imply having to really consider the Adeti said, like the materiality of things, and that's definitely going to have an impact on them. So I'm not really sure how they're transformative yet, but I think it's definitely a step in the right place to kind of move on for the next point. In terms of gentrification, well, from my understanding, like gentrification is often seen like as a bad thing, because you're basically making something which was bad, you make it good, essentially. But I think my position just for the project of gentrification is more like subtle kind of differences in work. And I think when you start to implement a bit, perhaps more of the kind of greenery environment, considering the region is quite fertile, then I think it's a kind of agricultural kind of. I'm not sure if I'm making much sense. I think that would increase the value of land in the sense that you're dealing with it more on an economic side. Because once you start producing crops and things like that, then you're able to kind of sell things to the people in the region. And also you're creating jobs for the people in the region, because Angola has, it suffers with high unemployment, and a lot of the people that live in this region have low education. And so you're kind of helping them to, I guess, become better citizens for the region. I hope that helps you in some way. In terms of the points that Ereti and Fanny were talking about, in terms of the the reflecting more on the detail of the design. I think at the point that I started was really kind of like, when I started looking into the fog collectors and understanding how high they were and how tall they were, and kind of understanding what kind of scale they worked on. Once you kind of establish that, then I think it then becomes easy to think. Because actually, I was thinking it personally as well. Is that you could kind of eliminate the mesh the vertical tower of them and perhaps play around with the fabrics of the mesh material. I don't know how they were quite. Maybe you will cover the city all over. You end up having kind of similar to. I'm just kind of thinking of Ksenia's project where you have this dome thing, and you might end up covering. So maybe you end up covering a particular region with this kind of mesh which is breathable. So I think it's really just down to going more into detail. And I think at this point, what I was really focusing was just kind of create a strategy that will help me then think about the architectural implications for the region. Because at this point, I can honestly say there isn't much of a strategy in terms of so the strategy of settlements in Angola is literally to displace the people and to build new things in that region. And you're not really doing much for the region because what's happening is, especially now with the oil crisis, it makes it a lot hard. You can't even build new things because there's no money to even consider. So you really do need to kind of work with the existing. Otherwise, so yeah, that's why I was kind of dealing with reflecting on information or on informality. But the next step will definitely be playing around with the material.
So again, thank you for the comment. Thank you for your presentation. I think, well, at the beginning of your research, you were talking about harbors and you were working during some time of that. But at the end, I think that you choose a very interesting subject, trying to work in a very specific place in the city, in these informal settlements. And I think that you took a good approach on trying to do, as you say, trying to develop regeneration, focusing as some other people did in the water aspect and others. I agree completely with Areti because I think that really we like from our students is that they really become activists and they really can do things more than making drawings, making things. So we hope that what you should do next is go in there and do your project because I'm sure these people will be happy and thankful for the idea of some people coming from Europe, coming back to their country and trying to help the development of the city with the knowledge that they acquire here. So and we hope that in 1 year you will send us a picture of that structure built in that city. Okay? In any case, thank you for your work and for your effort. I would like to offer Ruxandra to say some words just to close the presentation.
Okay, guys, you all have really amazing projects, and I'm so happy to have been part of everything this year. And the work is not done. In September, I expect some amazing development of your projects. I hope you took notes of all the jury comments. And well done. Congratulations, all of you. And see you on the 40th, and then see you in September.
Okay, and maybe the last thing, the director of the program, maybe Areti, want to say something?
I was not expecting that. I just want to say thank you guys for your effort. I'm always happy to be on the presentations of the second year because I do believe that you are the most mature minds inside the AC. And that's because you've already spent 1 year experimenting and then 1 year focusing on an individual project, which is not easy. We need to deal with our obsessions, we need to deal with our limitations, we need to deal with our professors, we need to deal with a lot of things. But I think that what I've seen today from all of the groups is very satisfying. The level of the project is really, really high, and that is what we expect from here, from what we take out from YAC. That's why I also want to congratulate Luis Viu and Zorti Paredes that they just escaped. as well as Vicente Guayard. I hope I will manage to congratulate Marcos Cruz as well tomorrow. Hopefully, the work will be as well good. But just one very small advice is the fact that I would really push you to think not as students but as professionals. So observe, I mean, take some rest, go to an island, whatever, but observe your project and see what is the potential of the project and push it. Don't leave it as a student project, because I think most of the things that you have been presenting today, they have a lot of possibilities for taking them further. So take them further and do them part of the professional work. And I think that's from me.
So thank you all, and I think there are some beer somewhere around. Thank you.
Guys, no beers yet. Wait. Wait, everyone sit it up. Back, everyone. You cannot leave now, because we have one more little studio, but very important. Please don't leave. Stay with us. So, Angelo. It's a last push, and then we have drinks and some music.
I have only one PDF.
I have a PDF.
No, but it's all a PDF. More slow, more simple. But I have a lot of work, and with this show, it's a 30% pay with my work.
I know. We find a way how to do that. And you will submit. Don't worry, we manage. Which one? This one?
Yeah, the first one, and the other. Manuel is an introduction.
Short one.
And the second one, yes, both.
This maybe. When you have, well, this is fine. No, this is fine. So I help you go. And you can feel comfortable. You can English, everyone. If you feel comfortable, present with your everything that you're developing. And then you always good.
Thank you.
You deserve it. You deserve it. So if it's let's just wait. Come back.
Well, I introduced this studio with one student. When Areti proposed me to follow Angelo, for me it was an honor. I think that, in fact, we were the last year together, and we had fantastic complicity with Angelo. Now I think that you will check that he's a very implicate student with his work, absolutely stimulating. And for me, in personal terms, it was a fantastic experience. The capacity to have one student, you can imagine, is a lux. You can go to take a copa, to take something, and in this case, the approach was very close. The project of Angelo is not easy because little relate with the Rosanna project. It's absolutely interested in the slums phenomena, the capacity to react these bottom-up, spontaneous, self-organized situations, and to be sincere, is in the limit of the architecture, because usually a lot of these phenomena are linked with economical, social, and other kind of levels of dynamic levels that you are not, in theory, able to control. But this is the thing, how to work not with the idea of control, but with other kind of ideas to orientate the things and not to control the things. And this is very interesting for us. I think that was a lot of generations that are interested in this kind of phenomena. And for Angelo, it was also very close of his country and his city, Lima, Peru. We had Diego that was also working there, and also your project was in relation with this kind of phenomena, because there are phenomena talks about dynamic systems, not static systems. They are talking about dynamic informational systems, and because they are informational, they are informal. Not they are informal because they are informal. They are informational because they are exchanging a lot of spontaneous information, and when you exchange a lot of spontaneous information, you are informal because you are not formal, or you don't work with predeterminate forms. And in these, in these situations, I think that we are absolutely entering in the substance of the YAC, of the dynamicity, the informationality, the capacity to work with process and not with objects. But this is the difficult. And for him, it was also not only abstract or theoretical, but it was absolutely important with the implication of Angelo with his country, his city, his neighbor, the origins of his context, and how to act there. It was for him an enormous challenge. No problem, Angelo. You have worked very well, and you have very well. He's a little nervous because there's a lot of interface problems, and we have 3 levels just to finish the global analysis in the world, a kind of taxonomy of some recursive situations in the world, and also Lima and the neighbor of, creo que es el mismo además, no, es otra ciudad. The slum neighbor of Lima, one of the different slums that can have a urban approach. It's not about, just to finish, architectural prototype. At the beginning, we tried to finish with something, how to explain, Aravena situation, a kind of prototype system of construction. No, it's more, the idea is to finish more in a line-wise, no? Line of orientation for these urban patterns and dynamic urban spontaneous systems. And perhaps in this rest of the summer, we finish with this approach to the prototype. Well, Angelo, now is your turn, no problem. And thank you very much for all these minutes of exchange and all this year that has been, in a personal way, fantastic. Angela, thank you. I know it's yours.
Thank you. In this investigation is about informal housing, and it begins by analysis from macro scale all the way to the most specific details. It begins with the global vision in the world, identify the large urban city on the planet, from the city that have major population to the small per continent. This is slums in the world: the city Mexico, the Sao Paulo, Lima, Peru, Quito, and analyzing this percentage urbanization, population, major percentage, and the amount of people living in slum. The source is an habitat, the World Bank, UNICEF, Urban Development Report. Subsequently, of all the cities that I have investigated, I begin to catalog for the most determined particular. In this part is the India, the population, the percentage for the urban world. This city is the slum inside the country. In this case, in this research, I have realized with the synthesis all the world, the 120 cities identified by but I have realized with a synthesis the 120 cities identified by population, by climate in this part, or that urban growth of the city communities. This information with the climate or the territory or the population, I overlaying all of this information. I identify informal housing in the world and selecting and zone in major area of concentration. Within this 120 cities, identify the quantity of population divided into 4 subgroups. One group 1 to 5 million. The second group is 6 to 10 million. The third group 11 to 15 million. 16 and more million. Is saying with the principal weather in the world, I have divide for the 4 groups, saying with the population and the urban growth territory. I have a divide for the 4 groups: the coast inside, coast side mountain, inside plain, inside mountain. For the 4 groups, inside mountain, this is a diagram, side plain, side mountain, when 4 groups for the explained territories, I identify these territories in the world. The red one is a mountain inside, the yellow is a plain inside, the green is a mountain coast, the blue is a plain coast. The conclusion mapping is overlaying all this information. The first one with a population by plain coast. This part is the slums. The second is a mountain coast. The third is a plain inside. The fourth is a mountain inside. The most concentrate is a mountain inside and mountain coast. Is the more concentrate with the slum. It is important to point out that more than 80% of informal housing are living in the city of Latin America and the Caribbean that are actually the most urban. Asia with a 47%, Africa is a 40%, India is a 30%. This information is based on research from an habitant. Now overlapping with the population, the territory, and the climate. This evident with a concentrate with this part in Latin America and Africa. This is the data. With this data, I make the diagram with warm desert climate is more concentrated with the other weather. The tropical climate, the continental climate, cold high mountain climate. In this analysis, I make for 4 groups with the families for the similar characteristic with the population, with the territory, and the climate. The first one family is a Colombia, Venezuela, Peru, with a 0.5 million. The other one is a Peru, Venezuela, Mexico. The second family, the third family, Brazil, Colombia, Argentina. The fourth family is Argentina, Brazil, and Mexico. And I concentrate with Latin America. Venezuela, Colombia, Mexico, Peru, and I concentrate with this family, Peru, Lima, Venezuela, Caracas, Mexico, Guanajuato. Because with this family is a mountain coast and inside mountain. I make with a catalog of patterns with Peru, Lima, Venezuela, Caracas, and Mexico, Guanajuato. I focus on the Peru, Venezuela, Mexico families in the city of Lima and Caracas, Guanajuato. By composition, this catalog, we can see that they present mountain territory. When leaving the city center or the coast, it is clear to see that the urban texture and structure change in a more spontaneous configuration. Now I focus on Lima. It shows an urban structure more variability and horizontal urban structure, which is intermediate, pendient, and more pendient. The Islam evolution in metropolitan Lima from 1950 to 2015. 15 is this is with this is a 1950 with a Islam is approximate 10%, with a 1970 is a 25%, 1985 is a 40%, and the last one, 2015, is a 53% with a Islam in the Lima city. In metropolitan Lima, I identify 6 slums which the community for high morbidity index and percentage of people younger than 40 years. In this case, the first one is Jicamarca, the second one Huaycán, the third is a Ventanilla, the fourth is a Cerro San Cosme, Victoria, the fifth is a Pamplona Alta, the last one is a Villa Salvador. With this is a 6 slums I find in this research, and I concentrate with the Jicamarca, Lima, Peru, because it's a more morbidity, and they have a problem, a big problem with the economy. This is the neighbor, Jicamarca. This is a variability for the territory. With this analysis in Jicamarca, now is with this population, the principal economy is a third sector. And the secondary sector is a 0.6%, and the primary sector is a 11%. This neighbor is 40 kilometers far from the city center, and its population is composed majorly by passing its coming and 11% from primary sector and 0.6 second sector, and 82.4 is a third sector. With this case, with a Jicamarca neighbor, the The principal problem is the economy, and la mejor forma que encontré para poder solucionar este problema económico es valorando la vocación del lugar, que es un pueblo campesino y ellos producen el 12% de cerdos para el consumo de Lima metropolitana.
¿Puedes repetir?
Dentro de toda esta ciudad, el principal problema económico es económico para una vivienda informal.
Within this context, the most important problem is economic for an informal settlement.
Entonces, no es un problema de la vivienda, sino es un problema económico en la cual encuentro cómo valorar la vocación del lugar.
It's not a problem. It's an economic problem in how to find the vocation of the place.
Que, como anteriormente dije, produce el 17% de consumo de cerdos para Lima metropolitana.
And this area produces about 70% of the consumption of pigs for the city.
Y actualmente Lima consume 30 kilogramos por persona al año.
And Lima, the consumption is 30 kilograms per person per year.
Que es una pena porque nuestro país vecino como Chile o Argentina consumen más del 70 kilogramos por persona al año.
And neighbor countries such as Chile and Argentina consumes about 70 kilos per person per year.
Entonces, dentro de esto, trato de valorar todos estos puntos que actualmente son 3 centros propuestos por el Ministerio de Vivienda, que son los más grandes, de 6 hectáreas, el segundo es de 4 hectáreas y el tercero es de 3 hectáreas.
So in the area there's been identified these centers by the Ministry of Agriculture, and they're areas of 6, 4, and 3 hectares within this neighborhood.
Entonces, coloco de una manera estratégica 6 puntos más para poder tener una economía propia del mismo barrio.
So 6 more points are identified, are placed in the neighborhood to generate an economy, a node economy in this neighborhood.
Un poco alejadas de las viviendas.
And they're placed strategically far from the houses.
Que cada una de estas tendrá entre 3 a 4 kilómetros aproximadamente, que tendrán una capacidad entre 800 a 1000 cerdos en cada centro. Teniendo este valor económico, ya podría plantearse una solución para la vivienda.
So based on this strategic economics, now a solution for the houses are proposed.
Esta es una vista de la propuesta que estuve planteando para la vivienda. Una pena no poder mostrarles el video que había preparado anteriormente.
So this is a proposal for the housing, what you're seeing, and he has prepared a video which is not sadly, he's not able to show today.
Bueno, con esta imagen puedo explicar digamos, la estrategia que hice para las viviendas. En la parte inferior se encuentran todo el barrio informal, pero cada año esto va creciendo desmesuradamente hacia la parte alta de estas montañas, pero de una manera muy espontánea. Y la toma de partido que he utilizado es coger estas líneas topográficas como punto de partida para poder hacer el trazo de expansión de estas viviendas.
So the strategy for the housing is based on because the slums, spontaneous housing, is developed in the plain, the lower plain, and is continuously growing. So the idea is to follow a strategy of continuing the contour lines to position the houses and to develop this strategic growth along the topography.
Y en la parte superior tenemos un área protegida en la cual se ha planteado todo este sector blanco que se está señalando, se ha planteado un espacio de transición para poder tener un control de expansión de estas edificaciones.
And on the top is proposed a borderline that is containing the growth. So this is a protection belt along the top to ensure that this boundary is not crossed.
Y estas áreas de color verde son los green production que habíamos planteado para que en esas zonas puedan montar algunas instalaciones para poder captar energía, captar humedad para todo este barrio, y a la vez puedan tener un espacio de agricultura.
And the green zones that you see here, these are areas that are designed to contain all the green areas, to produce energy, and to develop all the humidity requirements for the development.
Que las líneas o los elementos que se empieza a plantear de una forma aterrazada son las edificaciones en la cual propongo que serán de manera progresiva para la expansión de estas edificaciones.
So the contour lines, the housing are located in the contour lines, which are progressive housing that is going to be happening over time.
Eso sería todo.
The video was full of other layers, And this was one picture. The idea was to detect the three layers, reactivation of the existing in the plane, control, if you want, of the expansion, but not control, but more a kind of space with a filter between the nature and the existing elements that are disgregate in the mountain. And this is this filter landscape, and a kind of green active landscapes that go from top to the plane and connect also the public space there. In between these existing settlements and these green fingers, you have some bags, and these bags are the provision for the expansion, because this, as Angelo say, this neighbor is growing more or less, como iba, 50% cada año, ¿no? ¿Cuánto? No me acuerdo. ¿Cuál es el porcentaje de crecimiento previsto? ¿Cuánto? 45, 35% of growing every year, no? And it's evidently, you can say we stop, but in fact it's not possible. And the idea is how to conduct this in a kind of packs of density and have big spaces of connection with new